Hello dear students, I am Praveen, your chemistry educator. Students, I am guiding NEET aspirants from the past 13 years. Now, the point is, let's come on and let's start today's video, and let me tell you what we are going to do in this video. We are going to cover the full chapter, and that will be mole concept chapter. Students, you know that mole concept chapter is also known as some basic concept of chemistry. Now, in this video, what I am going to do, apart from discussing about the whole concepts, the individual concepts of the chapter, I will also tell you about the biggest problem that we face in chemistry. You know students, understanding a concept in chemistry is easy, right? In one go you can understand any concept, but the biggest challenge is how we can remember things for a longer duration. So in this video, I will tell you that how you can remember the concepts of this chapter for a longer duration, right? With help of backbone. Yes, you heard me right. I have created backbone of this chapter. Now students, a very good news for you. You know what? In this video, in the description section, you will be getting DPPs by which you can practice questions after watching the full video. Students, those DPPs you can also find on the PW app, right? In my name, Praveen Jha, and there also you can download the DPPs. And also, you know what? Lakhs of students are preparing for the NEET examination at PW and they are getting good ranks. So you also can be one of them. Now, without wasting any time, let's start this video. Students, in this video, what we are going to do, we are going to cover the whole mole concept chapter, which you also know as some basic concepts of chemistry. Students, after watching this video, after watching this session, you will be able to solve each and every question that you may get in your NEET examination, and that you can try, of course, with the PYQs. So students, let's start without wasting any time. And first of all, let us see that in this video, in this session, what we are going to cover, right? So first of all, we will start with backbone of the chapter. Yes, you heard me right, backbone. Backbone means in this chapter, we have a concept, a single concept. If you are able to understand that, so on that basis, you will be able to understand the rest of the topics we have in this chapter. Basically, the backbone concept is used everywhere in the rest part of the chapter, right? So after backbone, after looking at the backbone, we will see some of the basic terms that we use in this chapter, like what is atomic mass, what is molecular mass, what is atomic number, isotopes and all. After basic terms, we will see what are laws of chemical combinations. You know that you may have studied them even in your 9th, 10th class, but you can say we will have a quick revision of laws of chemical combinations. Then after laws of chemical combination, we will see percentage composition, empirical and molecular formula, and then counting or calculation of number of particle. Number of particle means you will have to calculate a number of atom, number of molecule, etc. Now, if you see carefully, so these are some of the topics we have in this chapter, which are little bit or easy to study or easy to understand. And there are some topics like stoichiometry, limiting reagent, percent yield, concentration terms, molarity, normality, molality, mole fraction, then law of equivalent and acid-base titration. So these are some of the topics which you will feel that a little bit lengthier side, right? It is a little bit difficult to do. But believe me, after this session, nothing will be difficult for you. Each and everything will be easy and each and everything will be doable for you. So now let's start with the very first thing, that is backbone of the chapter, students. Backbone. And it is very easy. You know what is the backbone? Unit conversion. Right? That means if you are able to understand conversion of units, then you are able to understand the whole chapter. Now students, even in your physics chapter 1, you have studied or you are studying unit and dimension, unit and measurement chapter. So in that physics also, you deal with units of lots of different parameter, right? In physics, like you talk about units of temperature, units of current, units of force, units of pressure, units of mass, etc. But in chemistry, at least in this chapter, we don't have to see those many parameters. We have to just focus on one parameter, and that parameter, students, it is amount. Of course, amount will be important for us, right? Because it's chemistry. In chemistry, we deal with chemical compounds. And whenever you do any experiment or whenever you do any type of calculation, so there you need to measure amount. Amount of what? Amount of chemicals, amount of compound. Now, point is this, whenever you do measurement or whenever you do measurement of amount, you will have to use certain units, right? And for amount, the units we are using in chemistry, they are gram, kilogram, mole, liter, milliliter, AMU. Correct? Of course, some of the units here you are seeing, they are very much known to you because you are looking at them from your childhood, like gram, kilogram, liter and ml. And one more thing is there. Gram and kilogram students, they are actually the units of mass, and liter and ml, they are the units of volume. But amount can be measured in terms of mass or in terms of volume and even in terms of number of particles. Whether you are measuring mass, whether you are measuring volume, whether you are measuring number of particles, right? All of them, they indicate what? Amount. See, if somewhere we have more mass means what? We have more amount. If somewhere we have more volume, right? That means we have more amount, right? In a container, if I have more and more number of particles, so more number of particle means what? There also I have more amount. So volume, mass and number of particle, right? In these terms, we measure amount, correct? Now, point is, I am saying that whenever you are measuring amount, you will have to use these units. And if there are multiple units, so you should know how to convert them, how to interconvert them. Now, of course, some of the conversions you know from your childhood. Like I don't think I will have to tell you that how to convert gram into kilogram, right? You know it, right? If amount is given, if mass is given in the units of gram, so that can be converted into kilogram just by dividing by 1000, right? And vice versa. If amount is given in the units of kilogram, then you can convert it into gram just by multiplying with 1000, right? So this is the way you convert gram to kg, kg to gram. And one more thing, focus here. Here 1000 is your unit conversion factor. 1000 is the unit conversion factor for gram and kilogram. And even if you talk about liter and ml, milliliter, so for them also the unit conversion factor is same, it's 1000, right? If I have to convert liter into milliliter, so what I will be doing? To convert a liter to milliliter, I will multiply with 1000 because in this case also our unit conversion factor is 1000. And if you want to convert volume or amount from ml unit to liter, you need to what? Again divide with 1000. So you can notice that these two you know very well from your childhood, liter ml, gram kilogram. And in both the cases, the unit conversion factor is what? 1000. Now let's talk about this unit, which is mole. Students, mole is also a unit in which we measure amount. More precisely, I should say here that mole is the fundamental unit to measure amount. I think in physics you must have seen that we have 7 fundamental units, right? So out of those 7 fundamental units, one fundamental unit is mole, right? And it is the unit of what? Amount. Now, point is this, think like this, that if I am saying ki gram, kilogram and mole, gram, kilogram and mole, all of them, they are units of amount. So there should be a relation. There should be a relation between gram, mole or liter, mole. And those relations are new to you and those are the relations where you have to focus. Students, whenever for any substance amount is given in the units of gram, right? Like 12 gram of carbon, 1.5 gram of water, right? 22 gram of carbon dioxide, 90 gram of calcium carbonate. So whenever for any chemical compound, for any substance, amount is given in the units of gram. So from gram, you can convert it into mole by dividing with the molar mass. Later on, you will see in basic part that what is molar mass, but here you can say that molar mass is our unit conversion factor. right? For any substance, whatever molar mass is there, so that will help you to convert gram to mole, right? And if you want to do reverse, suppose if amount is given in the units of mole, so that can be converted back into gram and again by molar mass, but this time you need to do what? Multiplication. So my point is this, try to understand like this. If gram kg conversion is there and its unit conversion factor is 1000, so similarly we have gram mole conversion here and its unit conversion factor is molar mass. Also, not only mass, even volume can be directly related to mole. You know what? If amount or volume is given in the units of liter, so we can directly convert liter into mole. But of course, there will be certain conditions to follow. If you want to directly convert liter to mole, so there are certain conditions that should be mentioned, right, in the questions also. Liter to mole conversion can be done directly by dividing with 22.4. If amount is given, like suppose if there are 20 liters of something, so that can be converted into mole by dividing by 22.4 and vice versa. Mole to liter can be done by multiplying with 22.4. But I told you that there is a condition that we have to see. Condition is this conversion liter to mole with 22.4 is applicable only for those substances which are present in gaseous state. Which are present in what? Gaseous state. And second thing is the condition should be STP. Right? So if in any question it is mentioned that we are using standard temperature pressure and the substances are gaseous state, right? So in that case you can convert liter to mole directly. Now students, these conversions, right, gram kg, liter mole, gram mole, liter mole, they are the most important part in this chapter. And don't worry, like whenever I will be talking about a new concept, so there I will tell you that this unit conversion, how we are using it, right? Now, after this conversion concept, now let's talk about some of the basic terms that we have in this chapter, right? And of course, some of them will be very, very easy for you, and some of them, some of the terms will be there which you are studying for from your 8th, 9th class. Like first of all, students, matter. I hope you all know what is matter, right? Matter is what? Anything which has a mass and which occupy what? Volume. This definition is from 9th class itself, right? Anything which has mass, which occupy volume, it is called matter. Now students, I have a very interesting question for all of you. Please write down in the comment box. If I am saying that if I have mass, I have volume for something, that is called matter. So suppose if something is there or some energy is there, because everything is energy, if some energy is there which does not have mass or which does not occupy volume, so what you will call it? If it has mass, it has volume, you call it matter. If it doesn't have mass and volume, then what you will name it, right? Now, matter, you can see in your surrounding, like whatever you see, table, pen, chair, water, everything is matter. But the main thing is, matter, according to their physical state, they have been classified majorly into 3 parts, right? Solid, liquid and gas. Now, of course, there are more types of states like BEC plasma, but here we are not going to focus much on that. Our focus majorly will be on solid, liquid and gas. Now, the basic difference between solid, liquid and gas is about their interparticle attraction. In a solid, the particles present, right, they have very, very strong interparticle attraction. But at the same time, if you look at the gaseous state, so in that case, the interparticle attraction is very, very low. And that's the reason in gaseous state, particles are very far from each other, right? The interparticle separation, the interparticle space is very high in gases, and that will be very low in solid. And liquid, everything is moderate in that. Liquid has less interparticle attraction as compared to solid, but it has more interparticle attraction as compared to gas, right? So I hope you all understand what is solid, what is liquid, what is gas. Now let's talk about the classification of chemicals or substances we have in chemistry. Students, the substance in chemistry that we use, that we see in the questions, can be categorized first of all into two parts: pure substance and mixtures. First of all, what is pure substance? See, whatever matter is there, whatever substance is there, they are made up of certain particles which is called constituent. For example, if you take pure water, right? So pure water is made up of H2O molecules. So for pure water, the constituents are H2O particles, H2O molecules. If you take pure iron, right? So for pure iron, the constituents will be Fe atoms, Fe ions, right? If you take graphite, so for graphite, the constituents are directly carbon atoms. So every substance, every matter, they have certain constituent, they have some particles from which they are made. Now point is this, students, if a substance is there, if a compound is there, which has only one type of constituent, if your compound has only one type of constituent, then it is called what? Pure substance. Like for example, you take pure water in a glass, right? Not the normal water, because they have certain minerals in it. So I am talking about pure water. If you take pure water, it contains only H2O molecules. Only H2O molecules. It has only one type of particle, that is H2O. If you take graphite, it has only carbon atoms in it, right? If you take oxygen gas in a container, pure oxygen gas, so it contains only O2 molecules. O2 molecules are the constituents of oxygen gas. So if a substance is there and it is composed of only one type of constituent, then it is called what? Pure substance. On the other side, we have mixtures. And I hope mixtures automatically you have understood. If a substance is there, if a chemical is there, right, in that you have more than one type of constituent, then it will be called what? Mixture. Suppose if I take a very simple mixture of salt and water, right? Salt water mixture. So if you take salt water mixture, there you will have H2O particles, you will have Na plus particles, you will have Cl minus particles, right? So in a mixture of salt water, we have three types of constituents: Na plus ion, Cl minus ion, H2O molecules, right? So that means it is definitely not the pure substance. It is what? Mixture. Even if you take like a mixture of ethanol water. So in ethanol water, you have two types of constituent. One is C2H5OH, one is H2O. So ethanol plus water, it is also a mixture. Now again, the pure substances, they are further classified as elements and compounds, right? Now, elements are those which has only one type of atom. One type of atom, right? For example, let's consider pure sodium. Let's consider pure sodium. Sodium metal. If you can look into sodium, of course it is not possible. You can't see the sodium atom at micro level. But in sodium atom, at micro level, you will see that we have only sodium atom, sodium ion, right? It has only sodium, only one type of atom. So it will be called element or pure element. Just like sodium, if you take any pure metal, iron, copper, zinc in pure state, so they have only one type of atom. Even if you consider oxygen gas, O2 molecule, so it has only oxygen atom. If you talk about fluorine gas, which is made up of F2 molecule, it has only fluorine atom. So if your substance is made up of only one type of atom, then it is called element or pure element. Now automatically with this, you have understood compound also, right? If a substance is there, if a pure substance is there and it has more than one type of atom, right? Like water, right? Water is a pure substance. It is made up of what? H2O molecules. But in the H2O molecule, we have two type of atom, hydrogen, oxygen. If you consider common salts, right, NaCl, it has two type of atoms, sodium, chlorine, right? So if a pure substance is there and it is made up of more than one type of atom, it is called what? Compound. And further, students, compounds, like here you can see an example. I have taken sugar, right? Sugar you know very well, right? On micro level, if you see, so sugar, it is made up of C12, H22, O11 molecules. Now in each C12H22O11 molecule, you can see that we have three types of atom: carbon, hydrogen and oxygen. So definitely sugar, you can't say that it is a pure element. Sugar is a compound, right? Now, those compounds, they are even further classified as organic compounds and inorganic compounds, right? Earlier, we used to say that those compounds which we get from the living things, they are organic, and which we get from minerals and ores, right? Rocks, they are called inorganic compounds. But in your 10th class also, in the carbon and its compound chapter, you have studied what is the exact definition of organic compound nowadays, right? Hydrocarbons and their derivatives, now they are called as organic compound, right? So here we have wheat, right? Wheat is one of the example of organic compound. It contains carbohydrate, and carbohydrate is nothing but organic compound. And like inorganic, if you see some example, so calcium carbonate is one of the example of inorganic compound. Not only calcium carbonate, right? Whatever mineral acid you have like HCl, H2SO4, HNO3, bases, NaOH, calcium hydroxide, more salts like NaCl, sodium carbonate, sodium bicarbonate, all of them, they are the examples of what? Inorganic compounds. Students, see, these are of course basic terms, but these are the things you need to be very good in it, right? You should be able to understand what is salt, what is acid, what is base, what is organic molecule, right? That's why we need to discuss these things also. Now, if you talk about mixtures, so mixtures are classified as homogeneous and heterogeneous. And again, it is based on how the constituents are arranged. Of course, you have already seen that mixture, it contains more than one type of constituent, right? Now, those constituents, if they are arranged in a regular pattern, like here you can see that if I have red particles and blue particles. So you can see even by looking at it, it is looking in a regular placement, regular arrangement. So if the constituent particles are regularly placed, regularly arranged in the mixture, it is called homogeneous. But if the arrangement of constituents, it is irregular, then it is called what? Heterogeneous mixture. And here we have some daily life examples of homogeneous mixture and heterogeneous mixture. Like ice in soda, soil water, they are some of the examples of what? Heterogeneous mixture. At the same time, air, still, rain, wine, these are the examples of what? Homogeneous mixture, right? Now, after studying these basic terms like what is element, compound, what is mixture, now let's talk about some of the fundamental terms, and these terms will be there in your questions also. Of course, you are not going to get direct questions from them, but indirectly in your questions, these terms will be mentioned, right? So first thing is, what is an atom, right? Atom, according to Dalton's atomic theory, if you see, it is the fundamental smallest unit of matter. Atom is smallest unit of matter, or it is the building block of matter. You can also understand atom, just for understanding purpose I am saying, you can also understand atom like this, that it is a system of charged particles. You know that atom contains electron, proton, neutron. Electron is negatively charged, proton is positively charged, neutron is electrically neutral. So atom is a collection of charged particles, system of charged particles, right? Now, for atom, there are certain terms which we need to understand, right, very well. And the first term is atomic number. I hope atomic number you all know from your 9th class, right? It is quite direct. Atomic number is number of proton. Just now I told you that atoms, they have proton, neutron, electron, and neutron protons, they are present in the nucleus. Here you can see we have a picture of atom, and this is nucleus, right? So inside the nucleus we have proton, neutron, and in the outside surrounding part, electrons, they oscillate or revolve around the nucleus. So for any atom, inside the nucleus, whatever count of number of proton is there, it is called what? Atomic number, right? Similarly, we have another term here which is called mass number, and it is also related with nucleus itself, right? Atomic number is only number of proton, but mass number is total number of proton plus neutron. So in the nucleus, whatever number of proton is there and neutron is there, if you add those, right, so that will give you the mass number of atom. And now the next term is atomic mass, right? What is atomic mass? I think it is self-explanatory. Atomic mass means what? Mass of atom. More precisely, mass of one atom, mass of single atom. You know, atoms, they are very, very small. So of course, if you measure mass of that much smaller particle, so their mass will be also very, very less, right? But still, the mass of one single atom, we define it as what? Atomic mass. And AMU is basically a unit in which you are going to measure mass of atom, mass of single atom. Right? AMU is atomic mass unit, and these days AMU is also called as simply U, unified mass. Right? And later on I will tell you that even AMU has a definition. AMU is defined as 1/12 of mass of C12 isotope. But I hope that you have done a quick revision regarding what is atomic number, what is mass number, what is atomic mass, and we use AMU to measure what? Atomic mass. Now, after atom, we have a question, right? Now, whenever a question will come, please use your PPB. Please use your PPB. What is PPB? See, in chemistry, PPB is a concentration term, right? In chemistry, it is parts per billion. But I don't mean here parts per billion. I mean here pen, paper, brain. Because this is the fundamental thing you need to study, right? So use your pen, paper and brain and try to solve this question, right? The question is very simple. It is based on atomic number, atomic mass, mass number. But you will have to do it. Question is the number of protons, neutrons and electrons in lutetium, and for lutetium atomic number is given 71 and mass is given 175. Correct? Pause this video here, do the calculation by your own, and later on you can match the answer, right? So if you solve this question, if you calculate number of proton, neutron and electron in lutetium, it will come out number of proton will be 71. Of course it will be 71, just by definition, right? I told you that here 71 is your atomic number, right? And atomic number is exactly equal to number of protons. So number of protons here will be 71. One more thing is there, students. If you take a neutral atom, we are not talking about ion, cation or anion. If you take a neutral atom, so in a neutral atom always number of protons will be equals to number of electrons. So in neutral lutetium, if number of proton is 71, automatically here the number of electron will be also 71. The only small calculation here you have to do is regarding the number of neutron, right? Here for lutetium, the mass number is given 175, correct? And we know that mass number is what? Number of proton plus number of neutron. Now, if mass number is 175 and number of proton is 71, so from here we can calculate number of neutron. Number of neutron will be, take 71 into LHS, it will be 175 into 71 will be 104. And this is the answer. Now, of course, this question is very, very simple, but remember, you got this in your NEET 2020 examination, right? Now, let's move further and let's see after atom, what is a molecule, right? Students, when atoms are grouped together, so group of atom is called molecule. Now, atoms will be grouped together, atoms will be bonded together by some chemical bond. So suppose you have certain number of atoms and due to certain reason, due to stability reasons, those atoms are combining with each other by some chemical bond. You know chemical bond, right? Covalent bond, ionic bond, coordinate bond. So due to any bond, if certain number of atoms they are combining, so they are creating a group of atom, and that is called what? Molecule. Here, for example, I have taken caffeine, right? It's a very common term, caffeine, right? You find that in your coffee and all. So for caffeine, if you see one molecule, so this is the structure of caffeine molecule. Yeah, now you don't have to go into the structure, you don't have to go into the bonding part right now. You have to just focus on that we have different atoms here and they are grouped together, like carbon atom, hydrogen atom, nitrogen atom, oxygen atom. So these different atoms, they are grouped together to form a molecule of caffeine, right? So overall, what is molecule? Molecule is group of atom, group of atom. Except at one place. Like when you take noble gases, right? So noble gases, they don't combine easily. So noble gases, they are always present in the atomic form. So there, even the noble gases, they are single atoms, still we call them molecule, right? So from except noble gases, whatever molecule you will see in that, you will always have group of atoms. Now students, for molecule, we have a term called molecular mass, and I think again molecular mass is self-explanatory like atomic mass, right? Like atomic mass was mass of one atom, so molecular mass will be mass of one molecule. One molecule. And the most interesting part is molecular mass we always calculate with help of atomic mass. In a molecule, whatever atoms are there, you simply add those atomic masses, you will get your molecular mass. And that's why the unit of atomic mass and molecular mass both are same. Both have AMU or U unit. Let's take an example. Let's talk about the very famous molecule, students, sulfuric acid, H2SO4. Now, if you observe H2SO4 molecule, again it is having group of atom. It has hydrogen, sulfur, oxygen atoms, right? And its molecular formula is H2SO4. Now here, if I have to calculate the molecular mass of H2SO4, so it will be simply mass of 2 hydrogen atom, which will be 2 AMU, because mass of 1 hydrogen is 1 AMU approximately, plus mass of 1 sulfur atom, which is 32 AMU, plus mass of 4 oxygen atom, which will be 64 AMU, because mass of 1 oxygen atom is 16. Now, if you add them all, it will come out 98 AMU. So students, for H2SO4 molecule, the molecular mass will be 98 AMU. Likewise, now you can find out, you can calculate molecular mass of any molecule. You just need the molecular formula. If you have the formula, from that you can easily find out what? Molecular mass. Now, after atomic mass, molecular mass, let's talk about some of the most important fundamental or basic terms, and from this you get direct questions also, right? They are, first of all, isotopes. Again, what are isotopes, right? They are the atoms of same element. Remember like this. Isotopes are atoms of same element. Why? Because when you talk about isotopes, so they have same atomic number, same atomic number, but different mass number, but different mass number, right? For example, let's consider hydrogen as element. When you talk about hydrogen, so hydrogen has 3 types of atoms. They are H11, H12 and H13. Now in these 3 atoms, you will notice that their atomic numbers are same. Of course it will be same because they are from the same element, hydrogen, right? So all of them, they have atomic number of 1. But if you notice, their mass numbers are different. One has mass of 1, one has mass of 2, one has mass of 3. So these 3 will be called as isotopes of hydrogen. One more thing, if you notice, if these 3 isotopes, they have the same atomic number, that means they will also have same number of proton and same number of electron, right? Apart from electron, proton, the different part here will be number of neutron, right? Like in H11, if atomic number is 1, then number of proton is 1, mass number is 1. So in this case, number of neutron will be 0. In this case, number of neutron, if you calculate 1, in this case, number of neutron will be 2. So in case of isotopes, mass number is different, and apart from that, even the number of neutrons will be different. But number of proton, number of electron, atomic number, those things will be same. Now, after isotopes, if you talk about isobars, so isobars, they just look opposite of isotopes. In isotopes, we have same atomic number, different mass number. But for isobar, we have same mass number but different atomic number. Same mass number but different atomic number. Now, because for isobars their atomic numbers are different, so definitely they are the atoms of different elements. They are the atoms of different elements. For example, let us consider nitrogen. Nitrogen has one of the isotope as N714. Means for nitrogen, here atomic number is 7 and mass number is 14. And we have another element, carbon, whose atomic number is 6, and for one of the isotopes of carbon, the mass number is 14. So now if you consider these two, nitrogen 714, carbon 614, so in these two cases, the mass numbers are same, 14, but their atomic numbers are different, 7 and 6. So these two will be called as isobars, right? So I hope you have understood what is isotope, what is isobar. So now let's talk about some of the self-explanatory terms. Yes, isotones and isoelectronic. See, isotones means those species which have same number of neutron, right? Same number of neutrons, right? And isoelectronic are those species which have same number of electron. I think you know that iso means same, electronic means what? Electron. So isoelectronic means those species which have same number of electrons, they will be called as isoelectronic, right? So now I think it is pretty much clear to you that what is isotope, what is isobar, what is isotone, and what is isoelectron. These terms you will need even in your next chapter, atomic structure, right? You will repeat those terms in your atomic structure chapter. Now students, we have one of the basic terms from which again you will get questions in your NEET exam, and it is average atomic mass. And let me tell you that this average atomic mass term for any element, it is calculated with help of isotope, with help of isotope. It is the percentage average of mass of different isotopes of an element. It is the percentage average of mass of different isotopes. Believe me, it's a very easy calculation. Just by one example, you will understand that, and then you will remember this point, average atomic mass, for your whole life. You will never forget that. You will even don't require revision for it. Let's consider, students, hydrogen again, right? Because just now I told you that hydrogen has three common isotope, H11, H12, H13. Also, this H11, whose mass number is 1, it is called as protium, right? The second one is called as deuterium, and the third one is called as tritium, right? Now, these three isotopes are present wherever hydrogen is present. Suppose if you take water, so you say that water is made up of hydrogen and oxygen. So in water we have hydrogen, right? Now, in that hydrogen, there will be protium, there will be deuterium, there will be tritium, but their percentage will be different, right? And their percentage, like in what amount they are present, in what amount a particular isotope is present, is called as percentage abundance or percentage occurrence, correct? So that data will be available for us in every question. Now here, let me consider that the first isotope of hydrogen, right, in nature, it exists as X%. Means whatever hydrogen is there, out of that, the protium is X%. And let's say that deuterium, it is Y%. Now automatically, the third isotope here, it should be 100 minus X minus Y, because total percentage is always 100. But let me write here as Z. It is Z%. And you should know that X plus Y plus Z will be 100. Right? Now, if I have the percentage abundance or occurrence of isotope, and if I have the mass of each and every isotope, From that data, I can calculate average atomic mass. Students, in this case, the average atomic mass of hydrogen will be mass of the first isotope, which is 1, into percentage abundance of the first isotope, which is X. Now just add them all one by one. Now the mass of second isotope, which is 2, into its percentage abundance, which is Y. Then again, mass of the third isotope, which is 3, into percentage abundance of the third isotope, which is Z, divided by total abundance percentage, which should be 100, right? So, mass into percentage abundance, their summation, whole divided by 100, it gives you the average atomic mass. And let me tell you one more thing, like whenever you see your periodic table, so in periodic table you will find that atomic mass of each and every element is mentioned. Now those atomic masses, they are nothing but average atomic mass. They are nothing but average atomic mass. So now I hope that you have understood how we can calculate average atomic mass, right? So take your pen, paper and brain again and try to solve a problem with me. Or you can do it before me. Just pause the video again, try to solve this question first, then you can match the answer with me. So question is, atomic weight of chlorine is 35.5. Now here, atomic weight of chlorine is given. So this is nothing but your average atomic mass. So for chlorine, average atomic mass is 35.5. Now, it has two isotopes whose atomic weights are 35 and 37. Right? So we have to find out what is the percentage of heavier isotope in the sample. Of course, if it has two isotope, one has mass of 35, one has mass of 37. So definitely here the heavier isotope is the one whose mass is 37. Correct? Let me help you here. If I have only two isotope and I assume that one has percentage abundance of X%, then the other one will have percentage abundance of 100 minus X. And just apply the formula of average atomic mass, you will get your answer. Right? So let's solve it now. First of all, chlorine, we know that its atomic number is 17. The masses are 35 and 37. And we have to find out percentage abundance of this, the heavier isotope. So let's assume that this isotope in nature, it is X%. So automatically the second isotope will be 100 minus X%. Right? Now just apply the formula of average atomic mass. For chlorine, it is already given that its atomic weight or average atomic weight is 35.5. So I can write like this. Average atomic weight 35.5, it should be equals to mass of the first isotope 35 into percentage abundance of the first isotope, which is 100 minus X, plus mass of the second isotope, which is 37, into percentage abundance of the second isotope, which is X. And again, whole divided by total percentage, which should be 100. If you do the calculation, you will get your answer. Right? Like 35.5 into 100, it will come out 3550 equals to 35 into 100 is what? 3500 minus 35 into X is what? 35X plus 37X. Okay, you should be good in calculation in chemistry and physics as well. Calculation is the most important part, right? Initially do it slow. Once you are accurate in calculation, right? Once you are accurately doing the calculation, then slowly you can increase your speed in calculation. But initially don't increase the speed. First go slow and be accurate. Now, 3550, if I take 3500 in the LHS side, it will come out 50. Minus 35 plus X plus 37X is what? 2X. So X will be how much? 25. So the heavier isotope will be 25%, right? And that is our answer, right? And students, again, you have solved one of the PYQs of NEET. This question, this particular question came in NEET 2014, right? And I hope that this type of question will be easily done by you. And one more thing, whenever you solve a question, see all the dimensions of the question. What type of questions can be framed from this? Like in average atomic mass, you can get only two type of problem. One type of problem will be like this, in which average atomic mass will be there and you will have to find out the percentage abundance or sometimes mass. And the second type of problem will be where the isotope, their percentage abundance will be given and you will have to simply measure the average atomic mass. Right? Now, after understanding average atomic mass, now let's talk about the second topic of this chapter, which is laws of chemical combination or rules of chemical combinations. Students, we will go into the details that what rules we have to follow for chemical combination, but don't you feel that first we need to understand what is the exact meaning of this term? We will see what are the rules. But first thing is, what is chemical combination? What do you mean by chemical combination? If you know, write down in the comment box, right? Chemical combination, what it is actually. So, chemical combination is nothing but formation of new chemical bonds. In chemistry, any process is happening. And during that process, if new bonds are getting formed, whether it is covalent, ionic or coordinate. So if new bonds are getting formed between your atoms, molecules or ions, so that is known as chemical combination. And for those combinations or those bond formations, we have certain rules and they are called as what? Laws of chemical combination. And the very first rule is law of conservation of mass. Again, you may have seen this topic in your 9th class, right? And the law of conservation of mass, it is quite easier to memorize. It is quite easier to remember because it simply says that mass can neither be created nor destroyed. Mass can neither be created nor destroyed. Or sometimes we also call it as whenever a chemical reaction will happen, the total mass of reactant will be equal to the total mass of product, right? The total mass of reactant will be equal to the total mass of product. So, mass is conserved. Mass cannot be destroyed, cannot be created. And this is evident from the Dalton's atomic theory, which says that atoms cannot be destroyed or atoms cannot be created. Although there are exceptions, like when you talk about nuclear reactions. So in nuclear reactions, we destruct atom and we convert into energy. But in chemistry, we do not talk about nuclear reactions, we talk about chemical reactions. So at least for chemical reaction, this law is 100% true, right? Now, let me tell you one more thing. If you notice carefully, in this chapter, we have two types of chemical combination, students. Two types of chemical combination. One is chemical combination of atoms, one atom, other atom chemically getting combined to form molecule. And the other type of combination is between molecules and compound. The chemical combination between molecules and compounds is nothing but your chemical reactions, right? Let me take an example. Let's say that I have oxygen atom. It is combining with hydrogen atom. So it will produce what? The stable thing will be H2O. And if I balance this, I will have to write it 2 here. That means one oxygen atom will combine with 2 hydrogen atom to give H2O molecule. So this is what you have as atomic combination. But on the other side, if I talk about this, that HCl, hydrochloric acid, combines with NaOH to produce NaCl plus H2O. So this is also chemical combination, but here we have combination of molecules like HCl and NaOH, and these molecules are combining to produce new compounds NaCl and H2O. In both the cases, new bonds are getting formed. In this case, a new bond is getting formed between sodium and chlorine, which is ionic bond, and hydrogen and oxygen, which is covalent bond. In this case, new bonds are getting formed between the oxygen hydrogen atom, which is covalent bond. So both are chemical combination, and these laws will be applicable for both the combinations. Like in this case, if you try to justify that by atomic masses or molecular masses, Like mass of one oxygen atom is 16 AMU, mass of two hydrogen atom is 2 AMU, mass of one H2O molecule is 18 AMU. So you can clearly see that the total mass in the reactant side is 18, in the product side is also 18, right? Similarly, for this molecular combination, if you see mass of one HCl molecule, it is 36.5, mass of one NaOH molecule, it is 40, mass of NaCl, it is 58.5, and mass of H2O is 18. Here also, if you add the total mass of reactant and total mass of product, it should be equal. So that just justifies law of conservation of mass. Now, a very important point for you students, in laws of chemical combinations, we have certain laws, but those laws we have to study in a different manner, right? Like law of conservation of mass, if you understand this, right? If you remember this, if you remember the definition, so that much is enough for you. But there are certain laws whose applications also we have to discuss. So those laws you have to focus more. And law of conservation of mass is not one of that. But the next one is law of definite proportion. In short, you call it LODP. LODP, law of definite proportion. And it is very much useful because from law of definite proportion, direct questions can be framed. So first, let us understand what is the meaning of law of definite proportion, and later on we will see that how or what type of direct questions can be framed from this. So students, law of definite proportion, what it says that you take any compound, right? Whatever elements are there in it, their mass ratio will be always constant. It does not matter from where you are getting the compound, right? For example, suppose if I take carbon dioxide from the environment, I collect carbon dioxide from the environment and I create carbon dioxide in the laboratory by reaction of carbon and oxygen, right? So whether I am getting from environment or whether I am creating it in the laboratory, in both the cases I am having what? Carbon dioxide, and it is made up of what? Carbon and oxygen. So in both the case, the mass ratio of carbon oxygen will be same, right? So the statement of this law is the ratio of mass of each element in a compound remains constant, right? The ratio of masses of elements will be always constant. For example, if I take CO2, so CO2 has carbon, CO2 has oxygen, right? In CO2, because formula is known, we have one carbon atom and the mass of one carbon atom, you can say it is 12, right? We have two oxygen atom, so mass of two oxygen atom will be 32. So this ratio remains always constant, right? From wherever you get CO2, in that ratio of carbon oxygen will be 12:32. And not only that, right? We can also relate the whole molecule. The mass of CO2 is how much? 44. That means the whole ratio remains constant. The ratio of C is to O is to CO2 is 12:32 is to 42, and this will be always what? Constant. And this is applicable not only for CO2 but any molecule, any compound. Now let me tell you from this LODP what type of direct questions you can get. Students, let's say I have some 90 grams of water. So I took a container, in that I have water and the mass of water there is 90 gram. So in 90 gram water, can you tell me what will be the mass of hydrogen or what will be the mass of oxygen? Right? It's interesting, na? In a container I have water, right? The mass of total water is 90 gram. Now I know that water is made up of hydrogen and oxygen. So can I get the mass of oxygen and hydrogen? Yes, we can get from this law of definite proportion, right? If I apply H2O, if I apply LODP, law of definite proportion for H2O, I can say that the ratio of hydrogen, oxygen and H2O remains constant, and the ratio is hydrogen having 2 atoms, so 2, oxygen is having 1 atom, so 16, and H2O's mass is 18. So this ratio is always constant, always fixed. Now from this ratio, what I can say that 18 part of water has 2 part of hydrogen. Means 18 gram of water has 2 gram of hydrogen. So I can easily calculate from unitary method that 90 gram of water, it will contain how much mass of hydrogen, right? Unitary method like this. 18 gram of H2O has 2 grams of hydrogen. So 1 gram of H2O has 2 upon 18 grams of hydrogen. So 90 grams of H2O has 2 upon 18 into 90 grams of hydrogen. And now you know that like this, I can also find out what is the mass of oxygen in H2O. So that's the one of the application of law of definite proportion, right? So we have law of conservation of mass, we have law of definite proportion, but we have to focus more on law of definite proportion, right? Now, after law of definite proportion, we have another law, but again, for this also, you should know just the definition part. We don't have much application for this. What this law states, what this law of multiple proportion states, that if I take 2 elements and those 2 elements combine to form 2 or more compounds, right? Now in those 2 compounds, if mass of one of the element is taken constant, then the ratio of mass of other element will be a simple whole number ratio. Now I know that just by saying the definition, it is little difficult to understand. So let me explain this with an example. Then you will easily understand this, right? Let's take an example. Let's say I have nitrogen and oxygen. So I am taking 2 different elements, nitrogen and oxygen. Now from these 2 elements, can I get 2 different compounds, at least 2 different compounds? Of course I can. One compound can be prepared from this is NO, nitric oxide, and the other compound can be prepared from this is NO2, nitrogen dioxide, right? Now just focus on the masses of element. In nitric oxide, because we have 1 nitrogen atom, so mass of nitrogen here, it will be 14. And for 1 oxygen atom, the mass will be 16. Similarly, in NO2, we have 1 nitrogen atom, so mass of nitrogen in this case will be 14 and mass of 2 oxygen atom in this case will be 32, right? Now this law says that 2 elements are forming 2 compounds. If mass of one of the element is taken constant or same, like here, if you notice, so for nitrogen, in both the compounds NO and NO2, mass is same. Here also 14, here also 14. So if mass of one of the element is taken same or constant in both the compounds, then the mass of other element, here oxygen, right, its mass will be in simple whole number ratio. Like in NO, the mass of oxygen is 16 and in NO2 the mass of oxygen is 32. If you simplify it, if you take the ratio, it will come out 1:2, which is a simple whole number ratio, right? So now I hope after this example you have understood what is law of multiple proportion, right? And we just need understanding of this. So now students, we are done with the laws of chemical combination, but if you notice, out of all those laws, the most important one is law of definite proportion. Keep in mind. Now, we have a very simple term called percentage composition. Basically, percentage composition is where you calculate mass percent of each and every element in a compound. It's a very simple calculation. Basically, we are studying this because it is a prerequisite of the next topic, which will be empirical formula and molecular formula and their calculation. Right, students? So, let me tell you what is the exact meaning of percentage composition again by example. Because see, in this chapter, everything is calculation. Even if you see questions of this chapter, so every question will start with calculate, right? Calculate empirical formula, calculate molecular formula, calculate number of particle, calculate amount, calculate molarity, calculate normality, calculate mole fraction. So every question starts with calculate because the whole chapter is about calculation. So if I have to calculate percentage composition, I will have to take some compound, for example, right? Let's take again H2SO4, right? In H2SO4, if I have to calculate percentage composition, means percentage composition of each and every element. So there are first of all three types of elements. One is hydrogen, one is sulfur, one is oxygen. So first thing is, first you get masses of individual elements. In H2SO4, I have 2 hydrogen atoms. So mass of 2 hydrogen atoms will be 2 AMU. Then I have 1 sulfur atom. Mass of 1 sulfur atom will be 32 AMU. Then I have mass of oxygen atoms, right? Mass of oxygen atoms will be how much? 64, because we have 4 oxygen atoms. 64. Now, what will be the total mass of all the elements or the molecule? It will be 98, right? So here, if I calculate what is the mass percent of hydrogen, sulfur, oxygen, so it is called the percentage composition. In this case, the percentage composition or mass percent of hydrogen will be mass of hydrogen, which is 2, divided by mass of the whole molecule, which is 98, into 100. You can calculate that further. In the same case, if I calculate the percentage composition or mass percent of sulfur, it will be 32 upon 98 into 100. And for oxygen, it should be 64 mass of oxygen upon 98 total mass of molecule into 100. So I think it is easy, right? For any compound, if you know the molecular formula, if you know the formula, you can find out mass percent or percentage composition of each and every element. So now students, let's talk about the next topic we have, right? Empirical formula and molecular formula. And let me tell you, it is one of the easier topics, but again, you get too many questions from this in your NEET exam. So first of all, let's understand what is the meaning of empirical formula and molecular formula. Then we will see how we can do the calculation. Students, empirical formula is the formula where you write down the simplest ratio of number of atoms we have in a compound. Empirical formula is the formula in which we write simplest ratio of number of atoms in a compound in a molecule. Right? Now, empirical formula is always easy to understand in comparison with molecular formula. See, empirical formula is the simplest ratio of number of atom. But on the other side, if you talk about molecular formula, so it tells you the exact number of atoms we have in a molecule. Molecular formula is exact number of atoms in a molecule or compound. So definitely molecular formula will give you more information as compared to empirical formula. But experimentally, we need empirical formula because from empirical formula only we get molecular formula. So experimentally, first we obtain empirical formula, and from that we calculate what? Molecular formula. That is why empirical formula is important. Now, first of all, let's understand both of them, empirical and molecular formula, with one example. Suppose if I take example of glucose molecule, right? So when I say glucose, in your mind, it should come C6H12O6. But students, the point is, for glucose, C6H12O6 gives you the complete picture, the exact information. That means what? If I take one molecule of glucose, so one molecule of glucose will have exactly 6 carbon, 12 hydrogen and 6 oxygen. Means if you look into the structure of glucose molecule, so in that structure also 6 carbon atoms will be bonded with 12 hydrogen with 6 oxygen. Right? So molecular formula definitely even gives you an idea about the structure and all. But in this, if you notice the number of atoms, it is 6, 12 and 6. Now, can we simplify it as a ratio? So, 6, 12, 6 can be simplified and can be written as 1 to 1. This can be simplified as 1 to 1. So, C1H2O1 or CH2O simply you write, because normally when it is C1, we don't write 1, we simply write it as CH2O. So, for glucose, the simplest ratio of number of atom will become 1 to 1. So, this formula that you are writing CH2O will be called the empirical formula of glucose molecule. And also, if you see, there is a connection between these two formula. In the empirical formula of glucose, if you multiply with 6, in all the number of atoms, right? So 1 into 6 will become 6, 2 into 6 will become 12, 1 into 6 will become 6, right? So if you multiply the empirical formula of glucose by 6, you will be getting what? Your molecular formula. And that's the relation we have in general between empirical and molecular formula. Actually, the molecular formula is always some n times empirical formula, right? N will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that n value can be calculated theoretically using molecular mass and empirical formula mass. Molecular mass and empirical formula mass, because it is ratio, right? So for a molecule, if you have the molecular mass and if you have the empirical formula, so from empirical formula you can easily calculate the empirical formula mass, right? Now, if you find out the ratio of molecular mass and empirical formula mass, so that ratio is n, and that n if you multiply in empirical formula, you will get your molecular formula, right? Now, first of all, we will see how do we calculate empirical formula with some example, and then you can practice more questions on it. But one more thing is there, one very interesting point is there. Like when you will be getting questions of calculation of molecular formula especially, so in that case definitely they will give you the molecular mass, because when they will give you molecular mass, then only you can find out n. But sometimes instead of molecular mass they can mention vapor density. So students, vapor density is a term which is a ratio of a particular gas, ratio of density of a particular gas to that of density of hydrogen. So I have gas X, its vapor density will be density of gas X divided by density of hydrogen. But that vapor density term, magnitude wise, we can relate with molecular mass. Molecular mass for gases is equals to 2 into vapor density. Please note down this formula, students, because later on you will require this to solve problems, to solve questions. That molecular mass, magnitude of molecular mass is equals to 2 times of vapor density, right? Now, let's try to understand with an example that how we can calculate empirical formula, then we will see how to calculate molecular formula. Now, if you know it already, if you know how to calculate empirical formula, do it by your own, pause the video, right? And if you don't know, just follow me, right? Just see how I am doing it. Question is, a compound X contains 32% of A and 20% of B. Now, the remaining percent are C. So, we have a compound X and they are saying that this compound has 3 different types of elements, and those elements are A, B and C. Now, the mass percent of A is 32. This is your mass percent given in the question. The mass percent of B is 20 and mass percent of C is not mentioned, right? No worries. We know that total mass percentage will be 100 always, right? So 100 minus 20 minus 32 will give you the mass percent of C. So 32 plus 20 is 52, and if you subtract 100 minus 52, so this will come out how much? 48. So mass percent of C is 48. Please don't consider it as a carbon, it's a random example ABC, and we have to find empirical formula. Now here comes the main point. Students, if you remember, at the start of session I told you what is the backbone, right? Unit conversion. Now, whenever you are calculating empirical formula, you just need to understand calculation of mole. In the questions of empirical formula, they will give you either the mass percent, or sometimes they can give you mass in the units of gram also. So whether it is mass percent, whether it is gram or in the units of gram, what you have to do, you have to just convert it into units of mole. And I have already told you how you can convert gram or mass percent into mole, just by dividing by atomic mass in case of atom, right? Or molar mass in case of molecules or compounds. So for ABC, I hope they have given atomic masses in the question, because that is required to convert these amounts into units of mole. So here you can see that atomic mass of A is 64. So from this, I can calculate now moles of each and every element. Moles of A here will be given mass is 32 or mass percent is 32 divided by atomic mass 64. And 32 by 64 students, it will come out 0.5. Similarly, for B, the given mass or mass percent is 20 and its atomic mass is how much? 40. So its number of mole will be 20 divided by 40, and again it is 0.5. Now in the third case, the mass or mass percent of C is 48, and for C, the atomic mass is 32. If you divide it 48 by 32, so it will be 1.5. So what we have done till now, we have just converted mass percent or gram into mole, right? And now you will get your answer. Basically, whatever number of moles you get here, correct? Just convert them into whole number. Just convert them into integer. Don't keep them in fraction, because you don't write formulas in fractions. So our next step will be, after calculating mole, we have to convert these values 0.5, 0.5, 1.5 into integers. And there is a very simple step to do so. Very simple step, and that you can follow every time whenever you are calculating empirical formula. And the step is, first step is, divide each term with the smallest value. Like we have three terms here, 0.5, 0.5, 1.5, and out of these three, the smallest value is 0.5. So divide each mole values with 0.5. Divided by 0.5, divided by 0.5, divided by 0.5. This will come out 1, this will come out 1, this will come out 3. Most of the time, just by dividing these fractional values with the smallest fractional values, you will get your answer in integer. Or sometimes you can do approximation. Here, up to plus minus 0.1 approximation is okay. You can do that. Like if it is 1.1, you can write it 1. If it is 1.95, you can write it 2. If it is 3.07, you can write it 3. So up to plus minus 0.5 approximation is okay here. Now, these mole ratios will give you the empirical formula, right? A1 is to B1 is to C3. So in this case, our empirical formula we are getting is ABC3. So I hope that now you will be able to calculate the empirical formula easily. Also, suppose here, after dividing with the smallest value and even after approximation, if you are not getting the values in integer, then you can do it by multiplying with some numbers like 2, 3, 4, 5. After multiplying with certain number, at the end ultimately you will get in integers. So here in this case, the answer is of course ABC3, and I hope that most of you have already done this. And again, this question came in the NEET 2013 examination. So you can see that in empirical formula part, what type of questions we will be getting in the exam. Now students, the next question I hope you should try first by your own. So again, use your pen, paper and brain and try to do it. Pause this video. Later on you can match the answer. The question is, a compound contains 40% carbon, 6.7% hydrogen and again 53.3% oxygen by mass. So again mass percentage is given. Now here you can see they have mentioned vapor density, right? I told you whenever you have to calculate molecular formula, either molecular mass will be given or vapor density will be given, right? So in this question they are saying for compound vapor density is 30. Now if vapor density is 30, so it is indirectly your molecular mass is given. If vapor density is 30, that means molecular mass of the compound will be 30 into 2, that means 60. So you can say that for your compound molecular mass is 60. Now calculate the molecular formula of the compound. Now we have to follow the same procedure, right? But you cannot get directly the molecular formula. First you will have to find out what? Empirical formula. So here if I do the calculation of empirical formula, again I have 3 different types of element: carbon, hydrogen and then oxygen. Their mass percentage are given. For carbon the mass percentage is 40, for hydrogen it is 6.7 and for oxygen it is 53.3. Now the only step, just calculate number of moles, right? So for carbon it is 40, atomic mass is 12, so mole will be, number of mole will be 40 by 12. If you divide it, it will be 12 3s are 36, 4, 3, 3. And for hydrogen atomic mass is 1, mass percent is 6.7, so it will be 6.7 divided by 1, 6.7 roughly. And for oxygen 53.3 is the mass percent and atomic mass is 16, so it will be 16 3s are 48, 5, 3, again 16 3s are 48, it is roughly again 3.33. So we got the number of moles, but again the problem is we got it in fraction. Now you know the step, right? First of all, divide each value by the smallest digit, smallest number, and smallest number here is 3.33. So if you divide all by 3.33, I hope this will come out 1, this will come out 1, and this will be not exactly but nearly 2, right, by approximation. So here the ratio of number of moles of each element is coming 1:2:1. That means the empirical formula will be CH2O. Right? Now, when we have obtained the empirical formula, we can easily get empirical formula mass. Empirical formula mass means mass of this unit. 1 carbon, 2 hydrogen, 1 oxygen. So mass of 1 carbon is 12, mass of 2 hydrogen is 2, mass of 1 oxygen is 16. So 12 plus 2, 14 plus 16, 30. So empirical formula mass is 30. Molecular mass is 60. So that means the value of N, remember N is molecular mass divided by empirical formula mass. Molecular mass is 60, empirical formula mass is 30, so this will be 2. Now if N is 2, empirical formula is CH2O, multiply 2 with each element's number of atom, like C1H2O1. So if I multiply with 2, it will become C2H4O2. So finally I can say C2H4O2 will be my molecular formula of the compound. Now I think at least after this question, you will be able to do empirical molecular formula completely, right? And even molecular mass is given or vapor density is given. In both the cases, you know how to get the molecular formula, correct? So now students, we have the answer, which is of course C2H4O2. Now, after empirical and molecular formula, one more thing is there, right? This chapter is based on calculation. So like I told you how to do empirical and molecular formula. So now it's your task to do lots of questions, right? We are providing the PPTs, we are providing the study materials for you, right? So download those PPTs from the video descriptions or from the PW app and practice all those questions which are based on empirical and molecular formula. Now with that, let's move ahead to the next topic of this chapter, which is mole concept, because in books we call it mole concept, and for understanding purpose you can say that it is counting number of atoms, number of molecules, number of ions, number of electrons, protons, neutrons, charge. Any counting type of problem you get, it is called mole concept. And it's a very interesting thing, right? Suppose when you are having a glass of water, you know that pure water is made up of H2O molecules, right? If it is pure water, so in that, in certain amount of water, I will have certain number of H2O molecules, right? A huge number of H2O molecules. Now, don't you feel it is interesting to count those number of molecules? If I have exactly 10 grams of water, so inside 10 grams of water, what is the exact number of H2O molecules I have? So those countings are called what? Mole concept. Now students, the counting part can be done in two ways. Now it's up to you, whatever you feel simple, you can follow that, right? But there are two ways to solve, to count number of atoms or number of molecules. One way is you can do it just in a statement form, written form, just by writing statements, right? And another one is make it in a formula based calculation. So I will tell you both, whatever is convenient to you, just follow that. Let's take an example to understand that calculation. Let's say I have some 9 grams of water. I have some 9 grams of water. 9 grams of water. Water means what? The formula of water you write always is H2O. So suppose this is the case. In this glass I have total 9 grams of water and my task is to calculate how many H2O molecules are there. Correct? So if I have 9 grams of water, what is the exact meaning of this sentence? Try to understand that. Here H2O is your substance, is your compound, right? And 9 gram is your amount. And in that amount part, 9 is the magnitude and gram is your unit. Now again, I am going back to my backbone because I told you in every topic I will mention it. Correct? Here students, to get number of particle, you just have to convert the unit from gram to mole. You are done. Right? And even it is given in some other unit, like in this case I took gram. If it is given in kilogram or in terms of volume, liter, ml, whatever unit is given, if you have to count number of particle, first thing is convert your amount into the units of mole, right? Now here it is gram, and if I have to convert this gram into mole, you know what to do. Divide with the molar mass, and molar mass, magnitude of molar mass is same as molecular mass. Always remember that. Although molecular mass and molar mass both are not same terms, they are completely different, but their magnitudes will be approximately same. So for H2O, you can easily get its molecular mass, it is 18. And if molecular mass, its magnitude is 18, then the magnitude of molar mass will be also 18, right? So in mole, it will be 9 divided by 18, right? And just complete the sentence now of H2O. So 9 by 18 means what? 0.5 mole of H2O. Done? What I have done? Nothing. Just a unit conversion from gram to mole. Now students, point is this, mole is no doubt, it is the fundamental unit of amount. But apart from that, mole or 1 mole also represents a number. 1 mole represents Avogadro number, which is 6.022 into 10 power 23. And not only mole, there are other terms also, which even you use in your daily life. Like when I said dozen. So dozen is a term, right? But you understand that dozen means a number which is 12, right? In cricket, when you say century, so century is a word, but you understand that century means what? 100. So in physics, chemistry also, there are huge number of terms which just indicates a number. Similarly, we have mole, right? Mole indicates this particular number 6.022 into 10 power 23. This means what? Anywhere, if this number is written, you can write it as mole. Or if anywhere mole is written, So you can remove mole, and instead of mole you can write this number, or vice versa. So in this case, if I have got 0.5 mole of H2O, I can simply remove this unit mole, and instead of that I can write this number. So now unit will be gone, you will have just a number without any unit, and that number in this case will be 0.5. Instead of mole I can write 6.022 into 10 power 23 and just complete the sentence of H2O. Done? So I got this number. It will be of course 3.011 into 10 power 23, but this number is of what? It is of H2O. And of course H2O is not ion, H2O is not an atom, it's a molecule. And this number we are getting for this molecule. So this number will be called as number of molecule. This is called number of molecule. So this is one way to solve this problem. Convert any unit into mole, replace mole by 6.022 into 10 power 23, you will get your number of particles, number of molecule, right? And the other way is formula based. You can create formulas from this. Like you can say that for any compound, number of mole will be given mass divided by molar mass. Then you can say that number of molecule will be equals to number of mole multiplied by Avogadro number. And after molecule, you can calculate what? Number of atom. Students, please do not get confused between number of atoms and number of molecules, because many students, they do mistake in this. You don't do that. Number of atoms, number of molecules, these are different things. Like here only, I calculated this number and this is the number of H2O. So this I will say number of molecule. Now suppose in 9 gram of H2O, if they ask what is the number of atom, so in this I will have to multiply with 3, because I can see that in one H2O molecule I have total 3 atoms, 2 hydrogen, 1 oxygen. So in one H2O molecule, if I have 3 atoms, so then these many number of molecules I will have into 3 number of atoms. And in the formula part, number of molecule is mole into Na. So number of atom you can write as number of molecule into atomicity. Atomicity is nothing but a number of atoms present in one molecule. Like for H2O, atomicity is 3. For Cl2, atomicity is 2. For helium, atomicity is 1. Right? So like this, students, I hope you can count number of molecule. And one more thing is there. Once you have calculated number of molecule, then you can calculate anything inside that. You can calculate number of atom. You can calculate number of proton. Suppose in 9 gram of H2O, if they ask what is the number of proton, so I will observe one H2O molecule. Inside one H2O molecule, I have 2 hydrogen atom, 1 oxygen atom. 2 hydrogen atom has 2 proton and 1 oxygen atom has 8 proton. So one H2O molecule has total 2 plus 8, 10 proton. So if one molecule has 10 proton, then these many molecules have how many proton? Into 10. So main thing is calculating number of molecule. Once you have got that, you can find anything inside it. Atom, molecule, atom, proton, neutron, electron, even charge and all. Right? So now I hope you have understood how to solve. It's your wish. You can do it in this form, statement form, or directly in formula form. Right? But let's practice some of the questions from this counting number of molecule, number of atom. Students, can you solve it by your own? Pause this video, try it first, right? Then do it with me. And then just have a comparison, how you are doing and how I am doing. Question is, the maximum number of molecule is present in. So here we have 4 options and we have to compare in which case we have maximum number of molecule. So of course for that you need to calculate the number of molecules in each case. Now the first case is 15 liters of H2 gas at STP. Now again, go back on to the first part of this video where I said about unit conversion, right? I told you that for gases at STP condition, when amount is given in the units of liter, so you can convert that into mole just by dividing by 22.4. So if I have 15 liter of H2 gas, its number of mole will be 15 by 22.4 and number of molecule will be 15 by 22.4 into Na, correct? Then in the second case, again we have gas at STP condition. If it is 5 liter, then number of mole will be 5 upon 22.4 and number of molecule will be into Na. In the third case, now we have amount in the units of gram. So here I will use molar mass now, right? For H2 gas, the molar mass is 2. And if it is 5 gram, convert it into mole, it will become 0.5 divided by 2 into Na is your number of molecule. And in the last case, I have again 10 gram of O2. So if I convert gram into mole, it will be 10 upon 32 and number of molecule will be 10 upon 32 into Na. Of course, you can do this much of division, or at least you can compare these values. And your answer will be definitely A option, which is 15 liter of H2. Because 15 by 22.4 into Na is the largest value here. And the most important point is, this question is from our NEET exam. It came in 2018. And these types of question of comparison of number of molecules, we get these days also, right? So it can be in your exam. When you will be giving the exam, so this question can be there. Now, can you do this question? Of course you can. Use your PPB. Question is, the number of atoms in 0.1 mole of a triatomic gas. This question is even much more easier because here we don't have to do conversions and all, because the amount is already given in the units of mole. So if the amount is 0.1 mole, I can directly say that number of molecule will be 0.1, replace mole by Avogadro number into 6.022 into 10 power 23. But here we have to calculate number of atoms, not number of molecules. And if it is triatomic gas, its atomicity will be 3, right? So multiply atomicity with number of molecule, you will get your number of atoms. So number of atoms in this case will be atomicity, which is 3, multiplied by number of molecule, which is 0.1 into 6.022 into 10 power 23. If you do the multiplication, it will come out 6 into 3 is 18 and 18 into 0.1 is roughly 1.8. So near about the answer will be 1.8 into 10 power 23, right? And the actual answer is 1.806 into 10 power 23, right? Now, can you do this question? I hope so, because this one is similar to the first one, right? Comparison of number of molecule. And in this case, all the amounts are given in the units of gram. So it is much more easier than that. In the previous question, we had in the units of liter and gram as well. But in this case, only gram has been used. So again, same technique, which has the maximum number of molecules among the following. So first, convert gram into mole. How? Dividing by molar mass. So 44 gram of CO2 will be 44 upon 44 mole, 1 mole. 48 gram of O3 means 48 by 48. 48 is the gram weight or amount in gram, and for O3 molar mass is 48. So it is also 1 mole. 8 gram of H2. So 8 given mass, molar mass is 2. This will come out 4 mole. And 64 gram of SO2. So given mass is 64. Molar mass will be sulfur atomic mass 32, O2 32, 32 plus 32, 64. So its molar mass magnitude will be 64. It is also 1 mole. So in this case, even by number of mole we can compare, because the one which has more number of mole, that one will have more number of molecule. So 1 mole, 1 mole, 4 mole, 1 mole. So definitely our answer should be C here, right? And of course that's the answer. Answer is C, 8 gram of H2. Now students, we have a question, right? It is not only from the previous topics till now that you have done in this session. Like it's not only from empirical formula or from counting number of particle. It's a kind of mixed question, right? Where you need again unit conversion also. Can you try it by your own first, all of you? Suppose the element X and Y combine to form two compounds XY2 and X3Y2. So we have two element X and Y, and they are combining, they are having some chemical combination, and they are giving two compounds. One is XY2 and one is X3Y2. Now, when 0.1 mole of XY2 is taken, its weight is 10 gram, and when 0.05 mole of X3Y2 is taken, its weight is 9 gram. So find out the atomic mass of X and Y. Let me give you a hint. This question is based on simple unit conversion, nothing else. Only unit conversion used. Or only you can say that this question is based on the backbone of the chapter. Students, let's say that for the element or atom X, atomic mass is small x, and for the element Y, atomic mass is small y. Now, because the formula is given, you can find out molecular mass, and the magnitude of molecular mass is same as molar mass, right? So molecular mass or molar mass of XY2 will come out how much? X plus 2y, and molecular mass or molar mass of X3Y2, its magnitude will come out how much? 3x plus 2y. These are your magnitude of molar mass. Magnitude of molar mass. Now go one by one. If I take 0.1 mole of XY2, so its weight is 10 gram. So both are same amount, na? Only the units are different. What's the relation between mole and gram? Mole is gram upon molar mass. So here mole is how much? 0.1. Gram is how much? 10. So it should be divided by molar mass, which is x plus 2y. Right? And same in the second one. For X3Y2, the number of moles are 0.05 and mass is 9 gram. So you can say that number of mole is given mass by molar mass, like formula. So number of mole here is 0.05. Given mass is how much? 9 gram. And in this case, molar mass is 3x plus 2y. I hope you know from your 10th class itself that if I have two equation and two unknown variables, I can calculate that. You can do the further calculation easily, I know that. And finally, the values of X and Y will come out 40 and 30. The answer will be how much? A. And this question again came in NEET 2013 exam. Right? So now I hope that after empirical molecular formula, you can comfortably do the questions of counting of number of particles. So now students, let's talk about the next topic of this chapter, which one you can say is the most important topic in this chapter, right? Because in your NEET exam, many times, most of the times you get questions directly from stoichiometry. And at many places you will see that even this chapter is named as stoichiometry itself, right? So let us understand first of all what is exact meaning of stoichiometry. What is the exact meaning of stoichiometry? Students, stoichiometry means calculation, again calculation of amount of reactants and products in a chemical reaction using balanced equation. Using balanced equation. You can say that balanced equation is the prerequisite in this topic. Using balanced equation. Right? So you will be getting certain types of problem here. What type of problem? Like you are doing a reaction. A chemical equation is written for that. Now in that you have reactant, you have product. Now for any of the reactant or product, if amount is mentioned, then using that we can calculate amount of rest of the reactants and products. That's what stoichiometry is, right? And in stoichiometry, you have to use unitary method again and again. Believe me students, even if you don't know the stoichiometry in chemistry, you already know stoichiometry in your daily life, right? Every day you are using stoichiometry or unitary method, right? Suppose I have a watch, right? The price of one watch is 5,000, correct? So if I ask you, what will be the price of 10 watches? You will immediately say, sir, 50,000, right? You will say it's a very easy calculation. but somewhere in your brain you are using unitary method here. You are doing like price of one watch is 5,000. That means price of 10 watches will be 10 into 5,000. That means 50,000. The same calculation of unitary method you will require when you will be doing problems in stoichiometry. So let's understand it first of all with a very easy example, and let us take my personal favorite equation, which is N2 plus H2 gives NH3. This is called a Haber's process, in which nitrogen, hydrogen, these two reacts to give you NH3. Now first of all, we need balanced equation, and currently this equation is not balanced. If I balance it, I will have to multiply H2 with 3 and NH3 with 2. Now, these numbers, students, like for NH3 2, H2 3 and 2 1, these numbers are called stoichiometric coefficients. And these stoichiometric coefficients are very helpful. You know what? They will directly give you the molar ratio for this chemical reaction, for this chemical combination. Like in what ratios the reactants and products will be reacted or formed. Correct? Like for N2 here, the coefficient is 1. It means 1 mole. For H2, the coefficient is 3. This means 3 mole. For NH3, the coefficient is 2. This means 2 mole. And this is always constant. This is always fixed. Just like your law of definite proportion. Just like your law of definite proportion. Right? And this ratio of mole for the reaction we are getting simply from the stoichiometric coefficient. And from this what I can say? I can say that whenever 1 mole of N2 will react, so that will always require 3 mole of H2. It's fixed. And also whenever 1 mole of N2 will react, it will always produce 2 moles of NH3. Done? And on the basis of this, you can do rest of the calculation for any amount. Like for example, suppose I am going into a lab, I am doing the Haber's process, and I took let's say 20 moles of nitrogen for a reaction. I took 20 moles of nitrogen for a Haber's process reaction. Now if I ask you how many moles of hydrogen I will require, right? You can easily calculate, just like the price of watch. Here also you have to use unitary method. How? Sir, 1 mole N2 needs 3 mole H2. Right? So 20 moles of N2 needs 20 into 3, that means 60 moles of H2. Not only that, I can also calculate how much maximum ammonia I can get, right? 1 mole N2 can give you 2 moles of NH3, double. So 20 moles of N2 can give you a maximum of 40 moles of NH3, right? So this is what stoichiometry is. If amount of 1 is given, we can calculate amount of rest. Right? Now you will say, sir, then this topic is very easy. Of course it is easy, but the calculations will be more and more. And how the calculations will be more? Due to unit conversion, students. Right? Remember, at the start of this session, I told you that the backbone is unit conversion. And the same unit conversion will be used again and again in this stoichiometry topic also. Right? Like suppose in this case, you get the ratio in the units of mole, using stoichiometric coefficient. But in your questions, the units can be different. They will not always ask in the units of mole. They will ask in the units of gram, kilogram, liter, ml, right? So you need to do some unit conversions there, right? Let me tell you one more example here using the same, my favorite equation, which is N2 plus 3H2 gives twice of NH3. Now suppose that in this case I am saying I have 10 grams of N2. I am taking 10 grams of N2. So with 10 grams of nitrogen, how many grams of hydrogen I require? So now this question can be solved like this. You have 10 grams of N2, convert that 10 gram into mole, right? Now from the molar ratio, calculate how many moles of H2 is required. Once you got the number of moles of H2, now convert it from mole to gram. So in this case, you will have to do conversion 2 times, mole to gram, gram to mole. Instead of doing that, what you can do, you can simply obtain the combining ratio itself in units of gram, right? Like in this question also, first of all, first thing is always write the molar ratio. Then only you can do in gram or ml or liter. Here the molar ratio is 1 mole reacts with 3 mole, produce 2 mole. Now 1 mole, 3 mole, 2 mole, this is the combining ratio in this case. Now what I can do, I can simply convert my ratio from units of mole into units of gram. And that is very simple, just multiply with what? Molar mass. So I have 1 mole of N2, N2 molar mass is 28, so it will be 28 gram. I have 3 moles of H2, the molar mass of H2 is 2, so 3 into 2 it will be 6 gram. I have 2 moles of NH3, now the molar mass of NH3 is 17, so 2 into 17 it will come out how much? 34 gram. So apart from the ratio in the units of mole, here only I can get my ratio in the units of gram. And of course, both will be fixed. Not only this, you can also obtain the ratio in the units of volume. Basically, volume has same ratio as mole. If 1 mole, 3 mole, 2 mole is the molar ratio, so in volume terms, it will be 1 liter, 3 liter, 2 liter. Correct? So gram, mole, liter, all ratios we can get from the balanced equation. Now, if I have to do this question, I will not use the molar ratio. I will use the gram ratio. Correct? I can say that 28 gram of N2 will completely react with 6 gram of H2. Right? So again, unitary method. 28 gram of N2 reacts with 6 gram of H2. So 1 gram of N2 reacts with 6 upon 28 grams of H2. Now if I am using 10 grams of N2, so 10 grams of N2 will react with 6 upon 28 into 10. Right? This is nothing but your unitary method. And this is what you have to use every time. Correct? So now I hope you all have got the basic idea of stoichiometry. That we have mole, gram, liter ratios. Amounts will be given and we have to do the calculation using unitary method. Right? So why not do some questions to understand stoichiometry. Now I hope that these questions is very much doable for you also. So pause this video and again try yourself first, right? Then only check the answer. Question is, the number of moles of hydrogen molecules required to produce 20 moles of ammonia through Haber's process. Again, we have got the same reaction, Haber's process, right? Here the balanced equation will be N2 plus 3H2 gives twice of NH3. Now in this question they are saying that we have used 20 moles of what? Okay, not used. We have got 20 moles of ammonia, fine. So we are getting 20 moles of ammonia. Don't worry, even product is given. From that you can find the reactant. So we have to find out how many moles of hydrogen is required. Fine. Now before doing the calculation, first you write the molar ratio from the coefficient. 1 mole N2 reacts with 3 mole H2 gives 2 moles of NH3. Now use unitary method. 2 moles of NH3, if you want to prepare, you require 3 moles of H2. So if you want to prepare 20 moles of NH3, you will require 30 moles of H2. Again, these calculations are based on unitary method. Suppose if you don't want to do unitary method, then you can do it by assuming X and by simply equating the ratios. Like this is one way doing it with unitary method. For 2 mole it is 3 mole. So for 1 mole it is 3 by 2. For 20 it is 3 by 2 into 20 it is 30. The other way to do is, suppose NH3 is given 20 mole. Assume that H2 is X mole. Assume that H2 is reacting how much? X mole. So the molar ratio remains constant. So 3 to this ratio and X20 this ratio should be equal. Just equate it, you will get X. Means 3 by 2 moles of H2 by moles of NH3 should be equals to X by 20 moles of H2 upon moles of NH3. And from here, if you calculate X, again you will get 30. So again there are two ways, either unitary method or by assuming X, just equating the ratios. So now I think the direct questions of stoichiometry, all of you can do easily. And please always remember, students, stoichiometry is the most important part, right? You need to be very good in this, correct? Now, of course, the answer is 30 mole here. We got that. And again, this is an easy question, but we got it in NEET 2019. And these types of problem, again, you will get, exam. Now, apart from the basic idea, fundamental idea of stoichiometry, we have few more terms here, which you need to understand. One of the term is limiting reagent. First of all, what is limiting reagent? It is that reactant which will react completely during the reaction. And the reactant which is reacting completely because it is present in less amount as compared to the other reactants. Right? It's I think common sense that if one of the reactant is present in lesser amount as compared to the stoichiometric ratio, then the one which is in lesser amount, it will react completely. And the one which is in more amount, it will be left. It is called excess reactant, right? So if you define limiting reagent, you can say that the reactant which is consumed completely during the course of reaction, right? Also, one more point is there. Suppose that in a reaction, if more than one reactants are there and for all the reactant amounts are given. So in that case, you need to first decide which one is your limiting reagent, because limiting reagent only will give you the correct amount of product. Amount of product will be always calculated on the basis of amount of limiting reagent. By mistake, if you have calculated amount of product using the excess reagent, believe me, you have got a wrong answer. So always remember that amount of product is always calculated by limiting reagent. So here we have to understand two things. First, what is limiting reagent, and the second thing is how to calculate that, how to calculate your limiting reagent, right? So let me explain that again with an example. Let's say I have a random reaction like twice of A plus thrice of B gives 4C. In this, A, B are your reactant, C is your product. Now in this reaction, I am using 50 moles of A and 50 moles of B. First thing is, whenever for two or more reactants amount is given, that means there can be some limiting reagent. First point is that. So if amount of A, B both are given, you need to check first which one is limiting reagent. And how to do that? Again, first of all, write the molar ratios. Here the molar ratios will be 2 moles of A will react with 3 moles of B and will produce 4 moles of C, right? Once you have written the molar ratio, the amounts are also given in moles. We don't need here gram ratios and all. To find limiting reagent, just divide the given amount with the ratio amount for each reactant. Like for A, the given amount is 50 mole and the ratio amount is 2. So 50 by 2, it will come out 25. For B, the given amount is 50 mole and in ratio its amount is 3. So 50 by 3, it will come out 16 point something. Don't do the full calculation because we have to just do a comparison here. By dividing given amount with a stoichiometric amount, the one whose value comes smaller, like here we are getting 25 and in this case we are getting 16 point something. So 16 point something is definitely smaller as compared to 25. So the one whose value is coming smaller will be your limiting reagent. So 16 point something we are getting for B. So in this case, B will be our limiting reagent. B will be our limiting reagent. And suppose in the same question, if I have to calculate what is the amount of product, so that can be done with help of limiting reagent, right? From B, I can calculate C, not from A. 3 moles of B can give you 4 moles of C. So 50 moles of B can give you 4 by 3 into 50 moles of C. But please always remember that we have to match the units. If given amount is in mole, then use the molar ratio to find limiting reagent. If given amount is in gram, then use the gram ratios, right, to divide to check the smaller value. If given amount is in liters, then use the liter ratios, right? Now students, after understanding limiting reagent, let's try to solve a question to understand in a much better way. And of course, if you have already understood limiting and excess reagent, you can do this question by your own. Pause this video, do it yourself, and then match the answer. Now, the question says 10 gram of hydrogen reacts with 64 gram of oxygen in a still vessel. Exploded means heated, reacted. Amount of water produced in this reaction. See, in this question, they are not asking which one is limiting reagent, which one is not. They are simply asking the product. But point is, they have mentioned amount of both the reactants. So automatically, it is our task to find out of those two reactant, which one is your limiting reagent. So first thing is, write the balanced equation again. Balanced equation here will be twice of H2 plus O2 gives twice of H2O, right? I am not writing the molar ratios now because it is self-understood. 2 mole, 1 mole, 2 mole. Because the given amount is in gram, so I can directly write the gram ratio, right? 2 mole H2, in gram it will come out 4 gram. 1 mole of O2, in gram it will be 32 grams. 2 moles of H2O, in gram it will be 36 grams. So this is the fixed combining ratio for this reaction. Now, they have given, the given amounts are 10 grams of hydrogen and 64 grams of oxygen. So to find limiting reagent, what we have to do? Just divide the given amount with the ratio values, stoichiometric values. So for hydrogen, given is 10, ratio is 4. So 10 by 4, it will be roughly 2.5, not roughly, exactly 2.5. In this case, given amount is 64 gram, in ratio it is 32, so 64 by 32 is 2. Out of 2.5 and 2, of course 2 is a small value, and 2 we are getting for O2. So in this case, O2 is my limiting reagent. Now once we got limiting reagent, we can find the amount of H2O. Again, by any method, by unitary method or by assuming X. Like suppose that I say 64 gram of O2 gives X grams of H2O. So I can just relate the ratios. 32 is to 36. 32 is to 36. Mass of O2, mass of H2O. And here it is 64 and X. 64 and X. Both should be equal. So now it will be how much? 32 into 2, 64. 2 into 36 is 72. So X will come out 72 gram. The answer should be 72 grams. Oh, the answer is 4 mole. Did I am wrong? Am I wrong? If my answer is wrong? Of course not. I got my answer in the units of gram, but they are mentioning in the units of mole. So it's my task to convert into mole. If I have 72 grams of water and the answer is mole, answer is in the units of mole, I can convert it. For water, molar mass is 18. So 72 grams in mole, it will be 72 upon 18, right? Which is 4 mole, right? So you should be, again I am telling you, you should be very good in the backbone of this chapter, unit conversion. And it is not very much, right? A little bit of conversion we require, gram mole, liter mole. And rest of the conversions you know from childhood, gram kg, liter ml, right? Now, let's do one more question. Again, Pause this, do it by your own. Then at the end you can check the answer. Question is 22.4 liters of H2, 22.4 liters is mixed with 11.2 liters of Cl2, mixed with 11.2 liters of Cl2 at STP. Why STP? Because this will help me to convert liter into mole. The moles of HCl formed is equal to. So this is the balanced equation here. Now in this case they have given amount in the units of liter, right? So what I can do, either I can convert these liters into mole here only, or I can do the calculation in the units of liter and at the end I can convert liter into mole. Both are fine. I am converting here only into mole because my final answer is in the units of mole. So students, if I have 22.4 liter of H2 gas at STP, so in moles it will be 22.4 upon 22.4, that means 1 mole. And if I have 11.2 liters of Cl2 gas at STP, it will be 11.2 upon 22.4, that means 0.5 mole. So these are the amounts I have. Now, according to this balanced equation, if I try to get the molar ratio, so here it is 1, means 1 mole, here it is 1 mole, here it is 2, means 2 mole. This is the perfect combining ratio we have. Now according to ratio, 1 mole is the combining ratio, combining value, and the given values are 1 mole, 0.5 mole. Here I don't have to even divide it to get the limiting reagent. Given amount 1 mole, ideal amount 1 mole, so 1 by 1 is 1. Given amount is 0.5 mole, ideal is 1 mole, so 0.5 by 1 is 0.5. Automatically for this you will get smaller value when you divide the given amount with stoichiometric amount. So Cl2 here is your limiting reagent. Now with help of Cl2 you can find HCl here. You can say that 1 mole of Cl2 will give you 2 moles of HCl, means double. So 0.5 moles of Cl2 will give you 1 mole of HCl, students, right? So answer will be 1 mole of HCl. And I hope that at least this question all of you have done by your own, right? This question all of you have already done. Now, can you do another one? But this time we have to calculate the limiting reagent and the excess reagent also. If there is an excess reagent, so some of the part of excess reagent will be reacted and some of the part of excess reagent will remain unreacted. So we have to find everything in this question. How much amount of excess reagent is reacting and how much amount of excess reagent is not reacting or remaining unreacted, right? Now the question is very simple. This reaction you may have studied in your 10th class also, combustion of magnesium, right? Burning magnesium ribbon and all. So 1 gram of magnesium Mg burnt with O2, of course it will produce magnesium oxide MgO, and if I try to balance it, here the coefficient will be 2, here also the coefficient will be 2. Now the question is, magnesium we are using 1 gram, O2 we are using 0.56 gram. We don't have to calculate product, which reactant is left in excess and how much. So first of all, get the limiting reagent. From limiting reagent, you can find that how much excess reagent is reacting. So amount is given in the units of gram. So 2 moles of magnesium, magnesium's atomic mass is 24. It will be 48 in gram. And 1 mole of O2, it will be 32 gram. So to get limiting reagent, divide 1 with 48. 1 by 48, let's say 48 is near to 50. So 1 by 50 is approx, let's say 0.02. You don't take it 50, you divide it with a proper calculation, right? 1 by 48. So 1 by 48 will be nearly 0.02. And here given amount is 0.56 and stoichiometric amount is 32. So this will be nearly 0.0, 32 to the 64, 1 something. So just by writing the first non-zero digit, I got the comparison. It is 0.02, it is 0.01. So of course 0.01 will be smaller as compared to 0.02. That means O2 is the limiting reagent here. Now point is, if O2 is limiting reagent, then the whole amount 0.56 gram will react. So what you can do, you can calculate that with 0.56 gram of O2, how much magnesium is getting reacted. Again, using unitary method. You can say that 32 gram of O2 reacts with 48 gram of magnesium. That means 1 gram of O2 will react with 48 upon 32 grams of magnesium. That means 0.56 gram of O2 will react with 48 by 32 into 0.56. Remove this decimal upon 100. 4 8s are 32. 28 into 3, 84. 84 by 100, 0.84. So 0.84 gram is the amount which is getting reacted for magnesium. Done. And total amount is 1 gram. So the unreacted amount will be 1 gram minus 0.84 gram. And it will be 0.16. It will be 0.16 gram. And this question we got in NEET 2014. Correct? And in exams, mostly the calculation parts are simple. Calculation parts are simple. You don't have to do lots of multiplication and division. In very few questions, you will get more and more calculations. Now students, in the stoichiometry part, let's talk about one point which is skipped by most of the students, right? They don't study or they don't solve many questions from this point, which is percentage purity. It's a very small point, but you get questions from this. And if you don't know what it is, you will be unable to solve the question. Percentage purity means whenever a compound is taken in the mixture form. Suppose you are doing a question of a stoichiometry and in your question you see terms like impurity, purity, or sample, mixture. So whenever you find these terms, impurity, purity, mixture, sample, right? Believe me, it is question related to percentage purity, right? Suppose if I say that I have a sample of 100 gram of calcium carbonate. As soon as I say it is a sample, there is a possibility that it contains impurity, right? If it is a sample of 100 gram of calcium carbonate, that means the whole 100 gram is not calcium carbonate. Out of 100 gram, some part is calcium carbonate and some part is impurity or some other compound. Now let us say if I say that for 100 gram sample of calcium carbonate, the percentage purity is 70%. So that will mean that out of 100 gram sample, only 70 gram is calcium carbonate. The rest 30 gram will be some other compound which we call impurity here, right? So from this percentage purity, let's discuss a question to understand that how we use percentage purity in the question part. Just read this question first of all of you carefully. What mass of 95% pure, here you can see that we are talking about a sample of calcium carbonate which is 95% pure. Means what? Whatever amount of sample you take, out of that only 95% will be calcium carbonate. Rest 5% will be impurity. Now let's see further what mass of 95% pure calcium carbonate will require to neutralize 50 ml of 0.5 molar solution according to the following reaction. Okay students, we will see concentration terms in today's session itself, but currently let me help you here. What you can do, if for HCl molarity is 0.5, volume is 50 ml, you can understand like this, that indirectly it is the number of mole. For any compound, if molarity and volume is mentioned, that means they have indirectly mentioned number of mole, right? Number of mole is molarity into volume in liter. So in this case, if molarity is 0.5 and volume is 50 ml, so number of moles of HCl will be 0.5 into 50 divided by 1000, right? So 5 into 0.5 is 2.5, and upon 100 I can write it as 10 power minus 2. So overall, this value indicates I have these many moles of HCl. Now you apply stoichiometry, right? I already have the balanced equation that 1 mole of calcium carbonate is reacting with 2 moles of HCl, right? Now, if HCl is 2.5 into 10 power minus 2 mole, so from this I can calculate how much calcium carbonate will react here. 2 mole HCl needs 1 mole calcium carbonate, which is exactly half. So 2.5 will require 1.25 into 10 power minus 2 moles of calcium carbonate. This means in this reaction, 1.25 into 10 power minus 2 moles of calcium carbonate is reacting. Now, we can easily convert it into gram. Because from mole to gram, we have to multiply with molar mass of calcium carbonate, which is 100, right? So if it is this much mole, in gram it will be 1.25 into 10 power minus 2 into 100, the molar mass of CaCO3 gram. 100 into 10 power minus 2 will be 1. So this will be 1.25 gram. So in this reaction, with this much amount of HCl, 1.25 gram of calcium carbonate is reacting. Now the main point comes here, right? To get 1.25 gram calcium carbonate, how much sample I will have to take, which is 95% pure. Suppose the sample has been taken X gram. Now the point is 95% of X gram should be equals to the required amount of calcium carbonate, which is 2.25 gram. So I can do the calculation of amount of sample like X, 95% of X should be equals to 1.25. And if you do the calculation, your answer will be roughly 1.25 into 100 is 125. 125 upon 95 is roughly 1.3 something. Yes, answer is 1.32 gram. So now I hope that after this question, at least you have understood what is the meaning of percentage purity. Right? Now, after percentage purity, let's talk about a similar kind of point. It is also small point, but it is used in the stoichiometry question. And this one is last point in stoichiometry. I'm not going to tell you more points in stoichiometry because this is the last thing. So apart from the basic concept of stoichiometry, we have 3 more points to focus on: limiting reagent, percentage purity, and the third one is percentage yield. Students, whenever you do something theoretically and experimentally, so there can be a difference. Suppose theoretically I calculated that 1 mole of N2 is giving 2 moles of NH3, but that will be the maximum amount. Means when everything is ideal, 1 mole of N2 is perfectly reacting, then only it can give you 2 moles of NH3. Now the same reaction if I do experimentally and if I take suppose 1 mole of N2, so there is a chance due to error I can get less amount of NH3. The error can be due to anything, due to not having the sufficient condition and all. So suppose experimentally with 1 mole of N2 I am getting only 1.5 mole of NH3. But theoretically I can get 2 moles of NH3. So their percent yield will be what is the actual amount you are getting, 1.5, divided by what is the maximum amount, theoretical amount you can get, 2 into 100. So percentage yield is defined as, and of course it is defined for products. The actual or experimental amount we get in a reaction divided by theoretical or calculated amount of the product into 100. Just write down the formula, actual amount upon theoretical amount into 100, and we will try to understand this term percent yield also with help of a question, right? See, just read this question carefully. It's a very easy question. I have taken this just to explain what is percentage yield. And it is easy, but again, same type of questions you will be getting in your exam. Question is 2x plus 3y plus 4z, 2x plus 3y plus 4z gives 5w. So in this case, xyz is your reactant, right? And w is your product, and 2, 3, 4, 5, they are your stoichiometric coefficients. Now, initially, 1 mole of x, 1 mole of x, 3 mole of y, 3 mole of y, and 4 mole of z, 4 mole of z is taken. 1.25 mole of W is obtained. So they are saying directly, we have obtained 1.25 mole. So obtained value means this is the actual amount you are getting, right? So this is the actual amount you are getting, 1.25 mole. Now what you can do, from the given amounts, you can do the theoretical calculation, and theoretically you can find that what is the maximum W we can get. But again, because 3 reactants are there, all amounts are mentioned, so first we need to get the limiting reagent. So 1 mole, in the ratio part it is 2 mole, 3 mole, 4 mole and 5 mole, right? So 1 mole is given, stoichiometric amount is 2, so 1 by 2 will be 0.5. Given amount is 3 mole, stoichiometric value is 3, so 3 by 3, 1. Given amount is 4 mole, stoichiometric value is 4, so 4 by 4, 1. 1.5. Of course, 0.5 is the smallest value here. So 0.5 we are getting for x, so x is your limiting reagent. X is your limiting reagent. Now from x, we can calculate how much W we can get. So ideally, 2 moles of x can give you 5 moles of W. So if I have 1 mole of x, which is half of 2, I will be getting 2.5 moles of W. But this 2.5 mole, it's a theoretical calculation. When everything will be ideal, right, the whole x will react, the whole 1 mole of x will react completely, then only you will get 2.5 mole, right? So this is theoretical value. But in this case, actual value is how much? 1.25 mole. So percent yield will be 1.25 divided by 2.5, actual by theoretical, into 100, and if it is, I think it's cancelling by 2, it will be 50%. So our answer in this case will be 50%. The percent yield of this reaction is 50, right? Of course, the answer will be how much? 50%. And this question, again it is easy, but you have solved a NEET PYQ. It came in 2015. So now students, I hope that you have understood stoichiometry and every details of stoichiometry. But again, you have to do a lots of questions from this, right? From the DPPs. Now, after stoichiometry, the next topic we have in this chapter is concentration terms. And again, concentration terms is the second most important part in this chapter. And also, many times in the stoichiometry part, concentration terms are also embedded. You saw one question where I helped you to get number of mole from molarity and volume, right? So that's why in stoichiometry also, concentration terms topics are used or embedded. So first of all, let's understand what is the meaning of concentration term. Believe me, just for the understanding purpose, if you see, it's a very easy thing to understand. Students, concentration terms are nothing but they are comparison. They are comparison. See, mathematically comparison means dividing. Like if you do A upon B, that means you are comparing A with B, right? 4 upon 2 is 2. That means what? 4 upon 2 means you are comparing the number 4 with 2. So 4 is 2 times bigger than 2. So comparison or division is nothing but your concentration term, right? Like it's especially for solution. This topic is for solution. Solution have solute, solvent. The one whose amount is less, you call it solute. The one whose amount is more is called solvent, right? Now, we are more focused on the solute part, which is present in less amount. Students, if you compare the amount of solute with either solution or solvent, so that is your concentration term. throughout the chapter you have noticed that we are again and again talking about amount. We are again and again talking about amount and of course their units. So in a solution, whatever amount of solute is there, if you compare or if you divide mathematically by amount of solution or amount of solvent, so that particular term, that particular expression is called as concentration term. For example, the most famous concentration term is molarity, which is very widely used throughout the chemistry. Molarity is denoted by capital M, and if you try to define it, it is a number of moles of solute in 1 liter solution. That's the definition. And from the definition only, we can create its formula. The formula for molarity is moles of solute divided by volume of solution in liter. Now, if you at least focus on the formula, you can say that here we are dividing amount of solute by amount of solution. So isn't it a type of comparison we are doing? Amount of solute by amount of solution. We are comparing amount of solute with amount of solution, right? And the main thing to focus apart from comparison is the unit part. Again, the backbone part. The backbone of this chapter is different units. In this comparison, what we do, we take amount of solute in the units of mole and we take the amount of solution in the units of liter. And that's why the unit of molarity is mole per liter, right? So I hope you all have written the formula of molarity, number of moles of solute divided by volume of solution in liter. So now students, let's understand molarity with help of a question. Please read this question, right? You will see that it's quite a direct problem. Students, in concentration terms, what you can do for your simplicity, you can divide the problems in 3 categories. Direct problem, mixing problem, and problem of finding one concentration term from another, right? Direct problem means this type of problem in which amount is given, volume is given, and directly from the formula you have to calculate the concentration term. Like here we have to calculate what? Molarity, right? In this case, if a number of molecule is 6.02 into 10 power 20, I think from number of molecule you can directly find mole, right? By dividing with Avogadro number. So here for urea, number of mole will be 6.02 into 10 power 20 divided by 6.02 into 10 power 23. Ultimately, it will be 10 power minus 3. And volume is given. Volume is 100 ml. In liter, it will be 100 by 1000 or 100 into 10 power minus 3. So finally, just by applying the formula of molarity, molarity will be number of mole 10 power minus 3 here upon volume in liter 100 into 10 power minus 3 here. 10 power minus 3 will be cancelled. 1 upon 100 will be 0.01, right? Unit will be mole per liter or unit sometimes simply written as capital M. So in this case, for this direct question, answer will be 0.01 molar. Now, after understanding molarity, let's understand some more concentration term, but please always remember in your brain that all of them, they are comparison terms. The only variation we have is unit. Only variation is unit. Like if you talk about molality. So molality is little bit different because in molality, you compare amount of solute with solvent, not the solution. Molality is defined as number of moles of solute in 1 kg of solvent. The definition is based on the formula itself. Molality denoted by small m, it is number of moles of solute divided by weight of solvent in kilogram. So isn't it again a comparison? Comparison of amount of solute with amount of solvent. And here solute is taken in the units of mole and solvent is taken in the units of kilogram, right? And the unit of molality will be mole per kg. And then we have mole fraction, right? Mole fraction is again a comparison of solute with solution. But this time solute is taken in the units of mole and solution is also taken in the units of mole. Now because solution is a mixture, so you can't directly find the moles of solution. So you do what? You add moles of solute plus moles of solvent to get moles of solution. But one more thing is there, mole fraction can be calculated for both solute and solvent. The mole fraction of solute is moles of solute divided by moles of solute plus moles of solvent. And the same can be applicable for your solvent. If you try to calculate mole fraction of solvent, so mole fraction of solvent will be moles of solvent divided by moles of solvent plus moles of solute. And the definition of mole fraction will be number of moles of solute present in 1 mole of solution. And for mole fraction, you won't have any unit because both numerator denominator has the same unit, that is mole. So I think after molarity, at least you have understood what is molality and mole fraction, right? Similarly, we have a few more but much more easier concentration terms like mass percent and volume percent, right? They all are comparisons. Mass percent means mass of solute to that of mass of solution, because it is percentage, so into 100. So you are comparing solute with solution, but unit will be gram for both or kilogram for both. Similarly, percent by volume means volume of solution, solute as compared to volume of solution. Again, both can be ml or both can be liter into 100 because it is percentage. So each and every concentration term is comparison. Only units are differing. Sometimes mole, sometimes kg, sometimes liter, sometimes gram, right? And the last two concentration terms we have is percent mass by volume. Now this is a little bit different and more useful. You will see that in many questions, percent weight by volume or percent mass by volume, because in this case, although we compare solute with solution, but for solute we take gram, the unit, and for solution we take the volume, right? So percent mass by volume is mass of solute divided by not mass of solution but volume of solution, and because it is percentage, so into 100. And for ppm, ppm stands for parts per million, means out of 10 power 6, right? So percentage is out of 100. Percentage is out of 100. So here you multiply with 100. Similarly, ppm is out of 10 power 6. So ppm can be calculated as mass of solute to that of mass of solution. For percentage you were doing into 100. For ppm you will do 10 power 6. Percentage and ppm, they are kind of similar term. When you calculate anything out of 100, it is percentage. But when you calculate anything out of 10 power 6, it is called ppm. And similarly, we can also have ppb, not that pen paper brain, but parts per billion. Out of 1 billion, if you calculate anything, so that is called ppb. Now, again students, let's see some of the questions from the concentration term. Take your pen paper now and try to solve it before me, right? Question is, the amount of glucose required to prepare 250 ml m by 20 aqueous solution. Now again, if you see according to the classification of questions, direct problem, right? Concentration, one concentration to another or mixing. So this is again a direct question we have. M by 20 means here molarity is 1 by 20. Volume is 250 ml and the compound, the solute is glucose, and its amount we have to find out. Just apply the formula. Molarity is 1 by 20. Molarity is number of moles of solute which is unknown, let's say n, and volume in liter, 250 ml is there, so in liter it will be 0.25. Now here if you calculate n, so n will come out 0.25 divided by 20. So these are the number of moles of solute. And if you have to convert it into gram, you can easily do that now. 0.25 by 20. The molar mass of glucose is 180. So mole to gram multiply by molar mass. You will get your answer. 0.25 by 20 into 180. It will come out 2.25 gram. So at least the direct problems of concentration term is easy, right? In which you just need to use formula of one of the concentration terms. Now, you don't have to do calculation here. In the next question, it's a little bit logical. But again, You can do it if you know the formula. Which of the following is dependent on temperature? So they are asking that out of these concentration term, which one will depend on temperature? Hint is the concentration term which will depend on volume, the same concentration term will depend on temperature, right? So you know that molarity is the one. Molarity is number of moles of solute divided by volume of solution. So because molarity depends on volume, that means molarity will depend on temperature. Any concentration term, if it is depending on volume, it will depend on temperature. So answer will be what? A, that means molarity, right? Now students, we have a different type of question from concentration term. It's not a direct problem. You can see that in this question, aqueous solution is mentioned. First of all, aqueous solution means our solvent is water. Mole fraction of solute we have to calculate, and 1 molar means molality of the solution is 1. So it is a type of question in which one concentration term is given and another concentration term we have to find. Here molality is given and mole fraction you have to calculate. Now let me tell you one strategy here. Whenever you get question like this, one concentration term is given, another we have to find, just assume volume of solution or weight of solvent according to question. Like in this question, the used terms are mole fraction and molality. Now in mole fraction or molality, none of them has volume in the formula. So in this case, we will not assume volume of solution. We will assume that weight of solvent is 1 kg or 1000 gram. But if your question is related to molarity, normality, right, which uses volume, so in that case, instead of solvent, you can assume what? You can assume volume of solution 1000 ml or 1 liter. And after that assumption, you have to do nothing, just apply the formulas. Those formulas whose concentration terms you have to find and whose concentration term is given. Like in this case, molality is given 1. So I will apply the formula of molality. Molality is 1. Molality is number of moles of solute, which is N here, divided by mass of solvent in kg. I have assumed it 1. So directly number of moles of solute will be here 1. Now I have to calculate mole fraction of solute, right? So mole fraction of solute will be moles of solute, which is 1, divided by moles of solute 1 plus moles of solvent. Moles of solvent, right? Solvent is 1000 gram and solvent is H2O. The molar mass of H2O is 18. So moles of solvent here will be 1000 upon 18, which is 55.5. 55.5. You can do the further calculations, right? It will come out 1 upon 56.5. But I hope you have got the idea how to do these types of problems of finding one concentration term from another, right? According to question, assume mass of solvent 1 kg or volume of solution 1 liter, right? In this question, of course, the answer will be 0.018. Now, can you do this question by your own? Can you all solve this question by your own? Because it is also same type of question, one concentration to another. In this case, 1 molar solution means molarity is given. Now before going into the question, I can predict here that I will have to assume volume in this case. Volume of solution is 1 liter or 1000 ml. Now molarity is 1. Density of solution is given 1.25 gram per ml. What is the molality? So we have to find molality. Molarity is given. Volume I assumed 1000 ml. Now just apply the formulas. Molarity is given. So molarity is 1 equals to number of moles of solute N upon volume I took 1. So moles of solute will be 1 mole. Now apply the formula, the one which you have to calculate. We have to calculate what? Molality. So molality will be number of moles of solute, which is 1, divided by weight of solvent. Now weight of solvent I don't have, but I can get it from the density volume. Volume of solution is 1000 ml, density of solution is 1.25 gram. So volume into density, I will get mass of solution, which will be 1250 gram. This is the mass of solution. But I need mass of solvent. So what I can do, Because I have 1 mole of solute and the molar mass of solute is 85, I can calculate solute in gram. Solute will be 85 gram, right? So mass of solvent will be 1250 minus 85, and to do into kg, divide by 1000, which will go up. You can do the further calculation. So now I think you have understood how to solve these types of questions where we convert one concentration term to another. The trick is just this assumption part, because after this we have to just apply the formula for the given concentration term and the one which you have to calculate. This question came in again NEET 2023, and here if you calculate further, your answer will be 0.858. So now students, let's talk about the final topic in this chapter, which is law of equivalent. Okay, why law of equivalent is important? Because I have seen many students skipping this topic also. Law of equivalent is important for you, especially when you deal with titration problems, whether it is simple acid-base titration, double titration, back titration, redox titration, right? In all those cases, you will require this law of equivalent, right? Now, to understand law of equivalent, we have to understand few more things. There are 2-3 terms which you need to understand first, then you can go for law of equivalent. The first term is equivalent mass. Again, it is related to chemical combination itself. Take any atom, any compound, any element, right? Whatever amount of that compound, element, atom is combining with 1 part of hydrogen or 35.5 part of chlorine or 8 part of oxygen, that is known as your equivalent mass, right? Let me tell you with an example here, then you will have a better understanding. Suppose that H2 reacts with Cl2 to give twice of HCl. Now in this reaction, you have seen stoichiometry just now. If I see the combining ratios or their masses which is combining here, for H2, 2 gram, and for Cl2, 1 chlorine has atomic mass of 35.5. So for 2 chlorine, it will be 71 gram. So according to stoichiometry, 2 gram of hydrogen will react with 71 gram of chlorine. So if I take 1 part or 1 gram of hydrogen, it will react with 35.5 gram of chlorine. So according to this, chlorine's equivalent mass will be 35.5. This is what I was saying here. With 1 part of hydrogen or 1 gram of hydrogen, what part or what gram of your compound is reacting, that is your equivalent mass. So this is how you calculate equivalent mass according to the equation, according to the reaction. Now, for equivalent mass calculation, we have a direct formula also. Equivalent mass or magnitude of equivalent mass can be calculated as molecular mass divided by n factor. Please note down this formula. Equivalent mass is molecular mass divided by n factor. Now, molecular mass you know, right? Molar mass, molecular mass you know very well. Now, what is n factor? First of all, let us see that. Students, n factor is a term which is quite similar to the term valency that you know from your 9th class. In your 9th class, you have seen combining capacity of atom is called valency. So in a broader way, instead of valency, we have n factor, right? Or sometimes it is also called as valency factor. Now, n factor, if you calculate that for atoms, so for atoms it is directly valency. For atoms it is directly valency. Suppose oxygen. Oxygen has a valency of 2, its n factor will be 2. Aluminium has a valency of 3, its n factor will be 3. Right? Hydrogen has a valency of 1, its n factor will be 1. So for atom, valency is your n factor. Now if you talk about acids, because acids, base and salt, at least for those, n factor calculation is important in this chapter. If you talk about acids, so for acids, whatever number of ionizable H plus ion you have, which is also called basicity, is your n factor. Like for H2SO4, it can give you maximum 2 H plus, so n factor is 2. For HNO3, 1. For H3PO3, 2. So for acid, whatever number of H plus it can provide maximum, that is your n factor. And I think from acid, you can easily guess for the bases now. In case of bases, ionizable OH minus, right, is your N factor. NaOH can give 1 OH minus per molecule, so that is your N factor 1. Calcium hydroxide can give 2 OH minus maximum per molecule, so for calcium hydroxide your N factor will be 2, right? And lastly, for salts, N factor is net charge on cation or anion. On cation or anion. Salts are made up of cations and anions. So take any salt, whatever charge is there on your cation or anion, anyone, that is your N factor. Like for example, if you take NaCl, in NaCl, the charge on cation is +1. So for NaCl, N factor will be 1. If I take calcium sulfate, so for calcium sulfate, the charge of cation is 2 plus, right? +2. So for calcium sulfate, N factor will be 2. So in this chapter, my point is, you should know how to get N factor of atom, acid, base and salt. Now, we need N factor for oxidizing and reducing agents also, and those things you will learn in your redox reaction chapter, right? Now, after N factor, you can easily find out equivalent mass, right? Because equivalent mass will be molecular mass divided by N factor. Now we go for the final point, that what is gram equivalent, or what is law of gram equivalent. Now, before we go into law of gram equivalent, we need to understand what is gram equivalent exactly. Or gram equivalent is also called as equivalent. Both are same. You call it gram equivalent, you call it equivalent, both are same. It is just a unit, students. Remember like this. I told you that mole is a unit of amount. I told you gram is unit of amount. I told you kg is unit of amount. So similarly, like your gram, kg, mole and all, gram equivalent and equivalent from today onwards, always remember that it is nothing but a unit for you. It is nothing but a unit for you. Apart from mole, the second most important unit here for amount in this chapter is our gram equivalent. And now, if I am saying that gram equivalent is a unit, so definitely it should have relation with gram, mole, the rest of the units. It has, and they are related with help of N factor first. Suppose if for a compound, amount is given in the units of mole. So from mole unit, you can convert it into gram equivalent just by multiplying with N factor, just by multiplying with N factor, and vice versa. If amount is given in the units of gram equivalent or equivalent, it can be converted back into mole by dividing with N factor. So N factor has this task also. It can convert the mole into gram equivalent and vice versa, right? So I hope from today onwards, you all will remember that gram equivalent is your unit to measure amount, right? Now, after understanding equivalent mass, N factor and gram equivalent, now let's finally talk about the law of equivalent, which is required for acid-base titration. Students, it is the most simplest law in this chapter. You know what it says? It says that whenever a reaction will happen between two substances, right? So their gram equivalents will be same. Equivalents or gram equivalents of A will be same as gram equivalents of B. Means what? See, in stoichiometry, when you measure amount in terms of gram or mole, the amount values are maybe different, right? But when you measure the amount, whatever amount is reacting in the reaction for the reactant, or whatever amount of product is getting formed, if you measure those amounts in the units of gram equivalent or equivalent, they will be directly same, they will be directly equal. So if A is reacting with B, equivalent of A will be equals to B. If an acid is reacting with base, that means equivalent or gram equivalent of acid will be directly equals to equivalent or gram equivalent of base, right? So for acid-base titration, for simple acid-base titration, at least from today onwards, always remember that whatever equivalents of acid you have, it should be equals to equivalents of base. And according to question, you can convert your equivalent into mole or into gram. Like equivalents of acid can also be written as n factor of acid into moles of acid, right? Equivalence of base can be written as n factor of base into moles of base. Further, even this mole can be written as given mass by molar mass. So according to question, we just put different expressions for equivalent in terms of mole, in terms of gram. Now, if you have understood gram equivalent, it is the right time to tell you about normality. In the concentration term part, we skipped one of the concentration term, and it is what? Normality. Now, why I skipped normality? Because it is very easy to understand once you understand gram equivalent. Students, normality is quite similar to molarity. Normality is similar to molarity. It is amount of solute by solution. The only thing is, when you calculate molarity, you take moles of solute, divide with volume of solution in liter. But in case of normality, instead of moles, you take equivalents of solute. So instead of mole unit, we use gram equivalent as unit here, divided by volume of solution in liter. So point is this, equivalent apart from mole and factor can be also calculated as normality into volume in liter. So molarity into volume in liter is number of mole, and normality into volume in liter is gram equivalent or equivalent. So please note down all these formulas of normality and equivalent equals to n factor into number of mole, right? If you have done that, now let's see a question to understand how we apply or where we apply law of equivalent, right students? So please read this question carefully. Question is, if 83 ml of 0.45 molar NaOH solution neutralizes or completely reacts with 235 ml of solution of HCl, calculate the molarity of the solution. Now, if HCl is completely reacting with NaOH, that means according to law of equivalent, equivalents of NaOH should be equals to equivalents of HCl. Now, according to question, transform this into molarity. Equivalents of NaOH can be written as normality into volume, and normality can be written as molarity into n factor. Normality, molarity have the same relation like equivalent and mole. Equivalent is moles into n factor, so normality equals to molarity into n factor. So equivalents can be written as molarity of NaOH into volume of NaOH into n factor of NaOH, and equivalents of HCl can be written as again molarity of HCl, volume of HCl, n factor of HCl, right? After this, you have to just substitute the values, you will get your answer. Molarity of NaOH is given 0.45, volume of NaOH is 83 ml, n factor of NaOH, NaOH gives you 1 OH minus per molecule, n factor is 1. Molarity of HCl we have to calculate, volume of HCl 235 ml, n factor of HCl, again HCl can give 1 H plus per molecule, so its n factor will be 1. You can do the calculation, you can find the molarity. So law of equivalent is always important. Whenever you see this type of question that acid reacting with a base, right, neutralizes, find molarity, normality, find amount. So in all those types of questions, you require this law of equivalent. In this case, if you calculate, your answer will be 0.16 molar. Right students? So now students, I hope that in this video, in this session of mole concept, you have understood each and every part, right? Whether it is law of equivalent, we are going in the reverse direction. Whether it is law of equivalent, question of acid base neutralization, whether it is a stoichiometry, whether it is concentration terms, whether it is empirical molecular formula, whether it is counting of number of particles, or the fundamental terms like isotopes and isobars, right? So after watching this video, I hope that I have helped you in your NEET journey, but please do not forget that what is your homework? Your homework is go to the PW app or in the video's description section, whatever PPTs or content is there, download it and please start doing practice, because easily all of you will become the rock stars in your chemistry journey. So keep rocking, keep preparing. All the best. Bye bye. We will meet in the next video of atomic structure. Over and out. Take care.